Hello, good afternoon, Shushma ma'am. Are you able to hear
Yeah,
me?
hi, good afternoon.
Hi,
Yes, I'm able to hear you.
that's
Hi.
great. That's great. Yeah. So we need to wait a little more for other participants to
Yeah,
join.
so I'm able to see participants has not yet joined, so we will wait for 5 to 7 minutes and then we'll start, yeah?
All right.
Yeah.
Let me know
So,
when.
hi, good afternoon once again, and good afternoon, participants. Welcome to this session on, just a minute,
Steam water cycle
on
chemistry.
boiler steam and water chemistry.
Yeah.
So, Banerjee Saab, just to update you, my younger brother is at NTPC and he's at corporate office and he takes care of boiler and turbine.
Then he may be knowing my name if he's.
Yeah. When I saw your resume, then
Hmm.
I just related. Uh, and recently he has been awarded with for some good practices what he have brought in NTPC.
Fantastic.
So,
Fantastic.
so.
So
mm,
he in Netra, NTPC Netra.
no, he is at corporate office Raipur.
Okay, Raipur. Yeah, yeah. They have purchased my book actually. 10 numbers of book they have purchased. I wrote a
Of
book.
yours?
Yeah, yeah. I wrote a
Okay.
book which is now famous in America and Europe very much. America, Europe,
Okay.
Australia, Japan. They're all purchasing my book through Google Books.
Good. So I will ask the reference of your books
Yeah, yeah.
while I speak to him.
Yes, yes. Definitely.
So he has been visited some foreign countries. NTPC has sent him for some projects and assignments to some foreign countries also.
Yes.
So he has been very much instrumental in bringing some new things, doing.
Especially Germany and America. NTPC is very much close to them with VGB Germany and EPRI. Plus, NTPC is quite close to Siemens Germany. Siemens Germany because of the turbines which they bring in India.
Just a minute. I believe there is some issue. How people have not joined? Only two. Mahendra. Link is okay. Just a minute.
I think people may not be available because of the short notice. We may have to, give some other time. महेंद्र जी, क्या आप बात कर सकते हैं, आप अनम्यूट करके? महेंद्र जी, आर यू एबल टू हियर मी?
Yeah, so Mahindra and Pratik, can you please unmute yourself and speak?
Yes, ma'am.
Yes,
ma'am.
So how people have not joined, can you please let me know? Because it's already 2:38.
Yes, ma'am.
Pratik
Madam,
ji, was it
From
a
which
short
you-
notice? Was it a short notice to make them
No,
join?
no. No. This has been communicated beforehand.
Okay.
People are joining.
Now
Joining.
Narendra Singh Thakur ji has joined.
So
Pratik
people
ji,
will be joining.
yeah, Pratik ji,
Let's
from which location are you in?
Sir, I am Dala,
Okay.
Uttar Pradesh, sir.
That's great. And Mahendra ji?
સર સેવાગ્રામ સિમેન્ટ ભુજ ગુજરાત.
वाओ, તમે ગુજરાતી છો? सेम टाइम, मतलब आप अच्छे, आपके नाम से तो आप राजस्थानी लगते हैं.
नहीं सर, मैं राजस्थान का हूँ बेसिकली, लेकिन
हाँ.
काफी टाइम से 30 ईयर इन अबाउट में बड़ोड़ा में अभी
ओके,
शिफ्ट किया है.
ગુજરાતી આવડે છે?
आवड़े છે सर.
हाँ, बराबर. नरेंद्र जी, आपने भी ज्वाइन किया, कहाँ से, कौन से लोकेशन से?
आंध्र प्रदेश ताड़ीपत्री से.
ताड़ीपत्री, इट्स वेरी नियर टू मी. आई एम फ्रॉम बेंगलुरु.
Yes.
ओके, आई स्टे इन बेंगलोर. राम दिनेश सिंह जी भी ज्वाइन किए हैं. And I
so
think
people will. I believe what
yeah,
happened.
five more minutes. Yeah, we have to give 5 more minutes.
So normally I share a reminder mail which I have missed today.
Oh,
So people want the last moment reminder also.
no, it's
So
okay.
you have so many mail communication for a single program. And today, because of some certain exigency and some other meeting happening continuously till 1 o'clock,
Yeah.
I simply missed this. I'm just realizing it. Acha,
No,
today I have not sent the reminder mail.
even the people in plant, you won't believe, you are in HR, but people in plant are actually very, very busy. All the time, there are so many meetings.
And that's why I'm thinking just to put a reminder mail now. Also, if they see, they will join it.
Yeah, at least we can wait 5 more minutes.
Yeah, sure.
Yeah.
I'm just putting a reminder mail.
Yeah, sure. By the time प्रतीक जी, महेंद्र जी, नरेंद्र जी और राम दिनेश जी, नमस्कार. मैं हिंदी भी बोल सकता हूँ अच्छी तरह, और अंग्रेजी भी बात कर सकता हूँ, बंगला और गुजराती भी बात कर सकता हूँ, क्योंकि मेरी मातृभाषा बंगला है, और मैं पला बड़ा जबलपुर एमपी में हूँ, और इसके बाद मैंने काफ़ी साल पावर प्लांट्स में काम किया है. मैंने शुरुआत किया अपनी ज़िंदगी का पावर प्लांट का यूके से, पावरजेन यूके से, जहाँ पर मुझे सीजीबी जर्मनी में, सीजीबी में लंदन में मेरे को 3 महीने का एक्सटेंसिव ट्रेनिंग दिया गया था पावर प्लांट केमिस्ट्री पे. उसके बाद पावरजेन यूके में था. फिर इंडिया में आया तो मैं भरूच में था. भरूच गुजरात में है, वहाँ 5.5 साल मैं था. उसके बाद मैं टाटा पावर में हेड ऑफ एनवायरनमेंट एंड केमिस्ट्री बन के 2006 में ज्वाइन किया था. और 2018 तक मैं लगातार पावर प्लांट्स को सर्व करता रहा हूँ एज हेड ऑफ द डिपार्टमेंट. मैं अदानी मुंद्रा में भी था 4620 मेगावाट में, जिंदल पावर में भी था, और उसके बाद लास्ट मेरा जो था काम एलपीजी से, ललितपुर पावर जनरेशन है उत्तर प्रदेश में, वहां पर था मैं। तो मेरे ख्याल से हिंदी ही ज्यादा सहूलियत रखता है बात करने में, है ना?
जी सर,
सर
जी सर, जी सर।
जी।
जी सर।
हेलो, yes Srinivas, tell me. No, I'm not free, I'm in a meeting right now, but anything urgent, or else connect me after 6:30. Okay Srinivas, right, thank you, bye. अभी उज्जवल जी और राकेश जी ने भी ज्वाइन कर लिया है. वी हैव नाउ 6 participants, and those six participants are good to go, but we can still wait for 2 more minutes. उज्जवल जी, मेरा नाम सौमित्र बैनर्जी है और आपके नाम से लग रहा है कि आप भी बंगाली हैं. उज्जवल जी, क्या आप अपने आप को अनम्यूट करके बात कर सकते हैं?
Good afternoon, sir.
गुड
Yes, sir.
आफ्टरनून
Yes, sir. Really, I am also Bengali, sir. Okay, sir.
सर.
It's nice to be joining for this session, sir. It's really will be nice for me. Yes, sir.
Which location are you from?
I am from Raccoon Cement Works. It's in Chhattisgarh, sir.
Is it near Bilaspur somewhere?
Yeah, sir. Yeah, sir. It's very near to Bilaspur. Near to Raipur also, you can tell.
Was it
nearest
earlier
rail-
Lafarge?
No, sir. It's Century Cement. It's a
Okay,
BK Birla.
okay,
now-
okay. It's a BK Birla Group. Okay, it
Yeah,
was a
earlier
BK
it was.
Birla Group. Yeah, okay,
Ah.
I understood. Because
Now it's
Raymond
not.
was once upon a time, Raymond was interested in taking up that
Okay.
job. Yeah,
Yeah, they are having plants there in Lafarge and Arasmeta.
yes,
Both plants are located in Chhattisgarh only.
that's great. And राकेश सोलंकी जी, आप कौन से स्थान से हैं, कौन सी जगह से आप अपने आप को रिप्रेजेंट कर रहे हैं? राकेश सोलंकी जी, क्या आप बात कर सकते हैं अपने आप को अनम्यूट करके? जब तक दूसरे लोग ज्वाइन करते हैं तब तक हम लोग आपस में बात कर सकते हैं, और प्रोबेबली हम बहुत इंपॉर्टेंट पॉइंट्स पे ही बात करेंगे जो कि नॉर्मली आपको कोई वेंडर नहीं बताता है. उन बातों पे ही हम गौर करेंगे आज. उसके बाद आपकी बातें सुनेंगे, आपको किस प्रकार की समस्याएं हैं, उसके समाधान देने की कोशिश करेंगे. We'll try to solve your problem during our talks. राकेश सोलंकी जी, क्या आप बात कर सकते हैं अनम्यूट करके?
Sir, Naren Singh talking.
हाँ
This,
सर, हाँ.
This is the Century Cement is the center of the Bombay and Nagpur, where Bombay and Kolkata. It is
Okay.
there is a just center. There is one pole
हाँ हाँ
where this that is the center of the Bombay and Kolkata.
Okay,
It is situated the Century Cement.
okay, okay. But you are from Tadipatri, right?
Yeah, I am working at Tadipatri, but I have studied in Raipur
अरे
and
वाह.
earlier, and
Wow.
I am from Mayhar MP actually.
Okay, I am from Jabalpur.
Yeah,
Okay, I visited Mayur number of times. Even
Yes.
I have my colleagues working in Mayur Cement as well. And Mr. Shakil Khan has also joined us now. So, ma'am, shall we start the training now? Or you
Yes,
can
yes.
say a
No,
discussion?
we will start. We will start. We will
Yeah.
start.
It's
Just
a-
a minute. Give me a
sir-
minute of time.
Okay, okay. तो शकील खान जी ने भी ज्वाइन किया है अभी. Now Mr. Umesh Babu has also joined.
Yes, sir, join, sir.
Yeah, Mr. Umesh Babu, from which location you are in?
Sir, Andhra Pradesh, sir. Andhra Pradesh Cement House.
Where exactly it is located? Near
Sir,
Vijayawada?
Tadapatri, Anantapur districts.
Oh,
Andhra Pradesh, sir.
Tadipatri. From where? Yeah. Tadipatri I know because it's quite near to me. I'm from Bangalore.
Sir, yes, I am from Tumkur, sir.
Oh, wow. Kannada Vartala is it?
Sir, Kannada, sir. Kannada, sir.
Okay.
Mother tongue Kannada. ಇಲ್ಲಿ ಕೆಲಸ ಮಾಡ್ತಾ ಇದ್ದಾರೆ ಸರ್.
Okay, that's nice.
Thank you, sir. Thank you.
Okay.
Okay, so सुमित्रा जी स्टार्ट करेंगे प्रोग्राम को.
That's great. I will
Yeah.
start, and ma'am,
No,
request you
just
to
hold on.
yeah,
Just
request
hold
you to
on, sir.
record
There
it.
are certain protocols that needs to be adhered for all the technical trainings, and the protocol is that we introduce the trainer, welcome the participants, and then we have a pre-assessment, small pre-assessment, and then we hand over the learning platform to faculty to start the session. Yeah.
Great.
So just give us 10 to 12 minutes, and then I will hand over to you to start the session.
Okay.
Yeah, okay. So good afternoon, participants, and welcome to this online session on boiler, steam, and water chemistry. The session has been aimed to make you understand on the various techniques of chemical controls and their effect on plant performance and failures. And the learning outcomes that has been set for this today half-day session is that you will be able to identify and understand the importance of chemistry parameters in boiler / steam water cycle. You might be, see, you people are all from TPP, then you might be understanding the chemistry parameters. Understand and able to analyze the effectiveness of steam water cycle chemistry, and of course you will be understand and have an ability to troubleshoot difficult situations encountered in boilers. Today's trainer is Mr. S. Banerjee, Sumitra Banerjee, and I take this opportunity and privilege to brief his profile. So he introduced himself as a seasoned power plant chemistry person and water treatment professionals, carrying with him in hand experience of 27 plus years. And he has done MSc in applied chemistry from Government Engineering College, Jabalpur in 1995. And during his last 27 years of professional career, he has worked with a number of India's pioneer organization handling India's pioneer water treatment company and giant private power generators in India like Tata Power, Adani Power, Jindal Power, LPC, GSCL as HOD Power Station Chemistry and Environment. He has both the experience of subcritical and supercritical power plants, commissioning, operation and maintenance, and troubleshooting of water treatment plants, boiler water, cooling waters, stator water, and wastewater. He was also associated with the reputed Institute of Power Technology as a faculty on water treatment and power plant chemistry. He has presented many papers on water treatment, power plant chemistry, and water management in national seminars and magazines, and has recently written a book. Recently can be the correct word?
Yeah, exactly. COVID,
written a book
during the COVID period.
titled as Practical Guide to Thermal Power Station Chemistry, and which is now being in top circulation in America, Europe, Australia, Indonesia, Bangladesh, and of course in India, even in NTPC. So yes, of course, I will definitely refer to my brother regarding this book. Few topics of published paper in international forums are reaching high COC in cooling water system to save water, energy, and chemicals. Flow accelerated corrosions and its prevention and monitoring. Monitor of heat transfer. See, I am just announcing all these papers in case you are facing some problem related to it. You just connect with Sumitra Banerjee, isn't it?
Right, they can.
Yeah. Yeah. Significance of water and steam purity in thermal power plant. Advanced method to optimize RO membranes performance. Proactive lead fouling indicator for all types of membranes. Using sensor data analytics, predictive modeling for improved effectiveness in thermal power stations. Developing organization strategies intends to achieve business excellence through Hossin-Conry concept. Tracking, tracing, and theft evading. New technologies of governance and the mining logistic industries. So that is different one.
Yes.
Not
Actually, I'm
not
also in IoT. I help American government and also American companies in Internet of Things, writing the algorithms and transfer functions for them. So
okay,
that is
great. So you are a software professional also?
no,
You write
no. I don't know the technologies, but
Yeah.
I'm writing algorithms and transfer functions so that they can put that in codings.
Okay. So you prepare the logics.
Yes, I prepare the logics.
Okay. Okay. So that is Sumitra Banerjee. So thank you, sir, and welcome to this session as a trainer and experts for the session topic. We will go ahead with the pre-assessment as a protocol of all the technical sessions, and I'm sharing the pre-assessment link and the barcode. So I have shared the pre-assessment link and the barcode. Participants, you are 10 minutes of time to complete this pre-assessment, and there are only 10 questions. So, but yes, of course, we are giving you 10 minutes to complete this pre-assessment. It's 2:53. We will start the session by 3:05. Okay. Over to you all. Over to you all.
And when the training starts, ma'am, please start the recording.
Yeah, sure, sir. So
Okay.
thanks for permitting, because I take a concession from the faculty whether I should go ahead, because that's their content. So that's why I take an agreement before I start the recording. So
And
thanks. You have only proactively said to start the recording.
And another thing that I've already shared the slides with Mr. Sunil
Sunil.
Shah,
Yeah.
yesterday. So please circulate these slides to all the participants as well.
Sure. So we normally, what happened, Sumitra ji, we have a GVC platform, GVC learning platform.
Okay.
So we put all these documents, all these presentations and recordings on that platform.
Fantastic.
And that's the learning management system platform where everyone can go and access the link at their own convenience. And it is 24/7 active. So,
Okay.
and we have categorized as E&I, TPP, process, mechanical, so that people of that area scope just simply don't go ahead either in the here and there. Simply go ahead with the focused learning you want to.
So that is
do
the
with.
knowledge management
Portal,
system.
knowledge portal, yes.
Yeah. And is there anybody from Rajula who has joined today?
Rajula Gujarat Cement Work?
Yeah.
Just let me see.
GCW.
So, is there any participants from GCW? Can you please raise your hand? Actually, the problem with this online session is that people don't come forward and speak.
No, it's okay. It's okay. Actually, they have their own priorities.
So, any intent of asking GCW unit?
Because uh, I heard that they were facing some challenges with their RO plants and also with their cooling water treatment. So that's why I asked.
Okay. So they will have queries. See,
Yeah.
our Ultratech people is having very great learning agility. So they will come forward with their cases.
Yeah. I have till now visited Gulbarga, your plant, and also I've visited your plant in that is called Utkal Alumina.
Hindalco.
Yeah. Utkal Alumina is in Orissa. It's
It's
Raigada.
under Hindalco.
Raigada. Yeah.
Raigada. Yeah, that's correct. I know. So the TPP operation head is Mr. Odisha person.
Okay, now he has changed. Earlier,
Parida. Mr. Parida.
Parida. Okay,
Yeah.
okay.
Yeah.
Okay. Mr. Kala is also there, right?
I don't know,
In
because I know
TPP
Mr.
operation.
Parida. That's why I know he's from Odisha, na? That's why. See, a small things makes a difference. Today, I have not sent a reminder mail. People, I believe they have missed it. They are joining. Now only I have sent the reminder. after half an hour, that the population, you will be able to see the population.
But they will miss the pre-assessment.
It's okay. Pre-assessment is normally, and as an average, what is the level of the learning they are having on this particular topic? And after this session completes, we have a post-assessment that gives us an insight. What was the average learning gained by the participants?
That is known as Kirkpatrick technology.
Level 1.
Yeah,
Level
level 1.
one.
Level 1. Yes.
Yeah.
Yes. I'm MBA in HR as well. So though I do not tell it clear in front of everybody, but that is actually required for running my own
Kirkpatrick.
business.
Okay.
Okay.
Okay. You run your own business.
Yes. It's my own company, Just Come Solutions Private Limited. Me and my wife are the directors, and we have people who are working for us.
Great. Good. So you are in the
I'm an
sharing your
entrepreneur.
knowledge and yeah,
I'm an
entrepreneur is
entrepreneur.
also.
Yeah, and starting
That's
with
okay.
knowledge company, and then slowly transforming into product company.
Product in the sense you are also selling some products.
Yeah, we are manufacturing chemicals and plants both.
Okay. Yeah,
So
Gopesh, you have raised your hand. Gopesh Sharma.
Yes, ma'am. Upesh Sharma from Sevagram Cement Works.
Yeah, Gopesh.
I am looking the desalination plant few years back and presently working in looking after the CPP operation.
wow, good.
Okay.
So we have 16 members right now, right?
Oh, great. And where is your office placed? Corporate office, yeah, office,
It is in
head
Bengaluru.
office?
It is in Bengaluru,
Bangalore.
Whitefield, because I
Mhm.
have to help TCE, Tata Consulting Engineers, because they do not have any chemistry expert. I have to help them in projects
Mhm.
to TCE, and then
Mhm.
I have all big companies as my, well, all big power plants as my customers.
Mhm.
Like Tata Power, Adani Power, Reliance, then all the plants of Karnataka Power Corporation Limited, KPCL, and then Jindals, JSW Billari,
Yeah.
and we have started in 2018, May 2018,
Mhm.
and
So when this COVID came,
we survived.
no. I said you started this entrepreneur when this COVID came.
COVID came in 220 March.
Uh-huh.
Actually,
Uh-huh.
I was in a tour in Eastern Africa. While when I went there, I saw everybody wearing mask and temperatures are being monitored. I was afraid what is happening. When I came back in India, same was there in India.
Yeah.
So yeah, we do export a lot of chemicals to Eastern Africa.
Mhm. Okay.
But my role is actually wherever I do consultancy, I do not sell anything, any chemicals or plants. But
Mhm.
wherever I
Mhm.
sell plants or chemicals, the consultancy goes free of cost with them.
Mhm. Yeah. Okay. Good.
So I sent it quite late yesterday night, that presentation. I
Acha,
don't know how Sunilji would have managed
So
to.
Sunil has not, I believe Sunil has not yet shared. Once he share, we will share with the concern with the
But
methodology that we
but how
upload the
that pre-assessment questionnaire can be made without the presentation?
no, pre-assessment questionnaire is the questionnaire. I believe the scope, what the scope of the this today's session has been kept in that scope only. The preparation has been done.
And if I deviate from the scope, if I do not know the scope, and if I deviate from the scope, then
So
they will.
I'm going to share. Why don't you click on the link of this pre-assessment which is available in the chat box and get the questionnaire?
I'll do that.
Yeah.
Uh, okay.
So participants, last 2 minutes, and whosoever has completed, please confirm in your status. Please confirm that you have completed it. Yeah. Okay. Thank you, Ujjwal. Yeah, Mahendra, you have raised your hand. Mahendra, you have to unmute yourself and speak, or you may put your concern on your this chat box. If you have raised your hand by mistake, please put your hand down.
Okay,
Last one.
all these questions has been derived from my presentation only.
I believe.
Yes, yes.
Yes, that's correct. So we have taken the help of our internal SMEs only to derive the questionnaires. Or I believe Sunil has created it and shared
Actually,
with us.
Sunil has created it because
Yeah, that's correct.
he asked me for the presentation to create this.
Yeah, okay. Okay, so Sumitra ji, over to you. Please start making the presentation.
That's
So
great.
thank you, participants. I would just see, I will like to inform you that session is being recorded and the recording will be done by me. Please don't interrupt the recordings, else the recordings will be, the effort will be futile one. Second is, yes, as a protocol of all the online sessions, put your queries, concerns in the chat box, or you may raise your hand, or you may raise hand.
Any question, anytime, ma'am. Okay, any
Yeah,
question, anytime.
okay.
They do not have to park the question.
Okay. So Sumitra ji ने permission दे दिया है. You may please unmute yourself and speak about your question during the session also. Yeah.
I'm sharing my screen now.
Yeah.
It's loading. I don't know why it's taking time.
Yeah.
No, something wrong went on. Actually, it's not getting
You
shared.
just close the entire thing. You just close the entire thing and then you start.
Close the entire thing.
मतलब PowerPoint पूरा close कर दीजिए, वापस खोल के फिर उसको
नहीं, the screen is not getting shared.
तो you just disconnect and then reconnect again.
Okay.
Yeah.
Okay, are you able to see the screen now?
Yes.
Okay, so we'll start now.
Yes.
Hello.
Put it in the slideshow mode.
Yeah, I'll do that. I'll do that. Just you see this is still working on. Yeah. So it will come on. Yeah, it has.
Just close this question tab. Close कर दीजिए.
Just a moment, ma'am. It has gone into security options. So here we go with the session today on steam water cycle chemistry. I will be only telling you the important points in steam water cycle chemistry. I may not be taking it completely because the time does not permit us to go for the complete thing. So first let's start with watching a video. We call it in training as icebreaker. Okay, let us watch a video regarding steam water cycle, how the water travels within a boiler, and how how there are different types of boiler, how they are being pushed, the water is being pushed, and how the pressure is being built inside. Right. So here we go with the video first. The first icebreaker. The network quality is not so good that.
So what I'm
This is
telling
the
this
inside of a boiler furnace. Here, water in the tubes lining the walls of the furnace absorbs heat from burning fuel. The water is boiled, producing steam that drives a turbine and also provides heat for other systems in the plant. Water circulation in a boiler is necessary for two reasons. First, it provides a constant supply of water to be turned into steam. And secondly, it carries the intense heat of the boiler furnace away from the boiler tubes, preventing the overheating and rupturing of the tubes. In a typical drum-type boiler, the water flow path includes an economizer, the boiler drum, comers, headers, and the boiler tubes. The water that is supplied to a boiler is called feed water. The first component that the feed water passes through is the economizer. The economizer uses heat from combustion gases that would otherwise flow out of the stack to heat the feed water. Heating the feed water means that less fuel has to be burned in the furnace to convert the water into steam. In this boiler, the heated feed water flows from the economizer and enters the bottom part of the boiler drum through the feed water inlet. The water continually circulates within the boiler through the downcomers, the lower headers, and the boiler tubes. A boiler typically has 2 or more downcomers and 2 or more headers. However, for clarity, this illustration shows only one of each. The lower headers supply water to the bottoms of the boiler tubes. The boiler tubes, which line the inside walls of the boiler furnace, are commonly called water walls. The water walls are exposed to the heat produced by burning fuel. As water flows up through the water walls, heat turns some of the water into steam. The mixture of water and steam rises until it enters the boiler drum, where it's separated into water and steam. The steam rises to the top of the drum, and the water remains in the bottom. The water is then available to recirculate through the boiler. The flow of water through some boilers occurs by means of natural circulation. The key to understanding natural circulation is the fact that cold water is heavier or denser than hot water or steam. In a boiler, the mixture of water and steam in the water walls is hotter than the water flowing from the drum through the downcomers. This is because the water walls are heated by the burning fuel in the boiler furnace. As the mixture of water and steam rises, cooler water from the downcomers flows into the lower headers and then into the water walls. The cooler water is also heated and rises, creating a self-sustaining flow through the water side of the boiler. Natural circulation of water in a boiler is affected by two factors. They are the amount of heat produced in the boiler furnace and the pressure at which the boiler operates. For example, raising the temperature in the boiler furnace increases natural water circulation.
आप म्यूट कर लेंगे अपने आप को प्लीज. आप किसी को कुछ काम का इंस्ट्रक्शन दे रहे हैं, उसकी आवाज यहाँ आ रही है.
Because it results in a greater temperature difference between the water walls and the downcomers. Increasing the second factor, pressure, has a negative effect on natural circulation because as pressure increases, the density difference between water and steam decreases. In some boilers, boiler water circulation pumps are
ये जो सब क्रिटिकल और सुपर क्रिटिकल बॉयलर है, इसमें सबसे बड़ा डिफरेंस ये है कि इसमें असिस्टेड सर्कुलेशन होता है. एक डाउन कमर में हमको एक पंप लगा के पानी को वंस थ्रू सिस्टम में डालना पड़ता है. ऐसे 600 मेगावाट के जो सिस्टम्स हैं इंडिया में, जो विद ड्रम है, ड्रम बॉयलर्स है, उसमें ये हर 600 मेगावाट में ये असिस्टेड सर्कुलेशन है. मैं इस वीडियो को और आगे इसमें केमिस्ट्री बेसिक्स नहीं है, लेकिन इसमें ये बताया गया कि एटम्परेटर कहाँ होता है, आपका सुपर हीटर कहाँ होते हैं, और इकोनोमाइजर तो आपको पता चल ही गया है. यू आर ऑलरेडी नोइंग वेयर इज इकोनोमाइजर. नाउ दीज आर द रीहीटर्स and these are the superheaters. Some are called radiant superheaters and some are called convection superheaters. So you may be all aware of this. If you're not, then please tell me. I will be running this slide again, running this video again after our training completes, means after the slides completes. Okay, we are having little short of time. Okay, we have to complete it within the time frame, so we'll be going through a bit faster. So that's how we go with the system, that a boiler water chemistry system or a power plant chemistry system always will be consisting of one DM plant, a water treatment plant consisting DM plant, maybe anion, cation, or ROMB or ROEDI, something like that, which gives the boiler makeup to the boiler, and boiler will be generating steam to run the turbine. Okay, here this is a very common picture of a small boiler, but you may be having a little bit higher pressure boilers. Maybe you may be running at 100, 120, 135 kg pressure boilers for your plants. Your cement plants normally has a problem of cycling, which we call it, sudden pressure. One kiln is down, so you have to get down the boiler generation, steam generation, and there will be sudden drop in pressure and everything, and then you have to again bring it up. So ramping up and ramping down time is a problem for a cement plant. I've seen few plants where there are 4 or 5 kilns, and even one kiln down means they are already 25 megawatts down. So that is one of the problems you may be facing, which I know. But there are several other problems in any power plant chemistry, in water treatment department, and in steam water cycle chemistry. We'll today mainly focus on the stream water chemistry. Okay, and then I will also take your questions one by one within this time frame, so that we can talk upon that. यदि आपको अंग्रेजी में मुश्किल होती हो तो आप मुझे बोल सकते हैं, मैं हिंदी में भी अच्छी तरह आपको ये प्रेजेंटेशन दे सकता हूँ. तो अभी मैं अंग्रेजी में कंटिन्यू कर रहा हूँ, लेकिन अगर आपको परेशानी है अंग्रेजी समझने में, मेरी यदि प्रोनाउंसिएशन को समझने में परेशानी है, तो प्लीज आप मुझे बताएं, तो मैं आपको हिंदी में भी बता सकता हूँ. So the first point a power plant chemistry department should need in a power plant, okay, or a steam generator, is producing quality steam, which will actually depend on the managed water treatment. There are two treatments of any boiler, one is internal and one is external. Okay, so internal treatment they have to manage, and also they have to manage the external treatment. I will be taking you to few important points where the water treatment fellows, they do not tell you generally. Okay, so boiler performance, efficiency, service life, and control, all these are a direct relation, having a direct relation of controlling the feed water used in boiler. Most of the components in the feed water are soluble, so whatever we add, ammonia, hydrazine, or your TSP, trisodium phosphate, all these are soluble. However, some of them like phosphate, phosphate can form some kind of deposit even inside the boiler, which is also known as maricite. With sodium, iron, and phosphate, they form a deposit and they cause gouging. That phenomena in totality is known as acid phosphate corrosion, which specially happens in the rifle tubes. Okay, that I will take in a separate uh, session on boiler tube failures. At that time, I will tell you more about that acid phosphate corrosion. Now we'll talk about some important points in steam water cycle chemistry. So we know that deposits and corrosion results in the efficiency loss of a boiler, and also some corrosion causes loss, deposit and corrosion on the turbine blade causes loss in efficiency of the turbines as well. So we'll go ahead. The first point which you must know that both EPRI is the standard for all the power plants. Okay, Electrical Product Research Institute America, which also governs NTPC water chemistry, and NTPC not only water chemistry, all mechanical C&I and everything they govern. NTPC follows EPRI. Before 2003, we were following VGB Germany, and that is still existing. Okay, VGB is also a standard company, which the Europe follows it entirely. Europe and also some part of Australia still goes with VGB. Though VGB and EPRI are not very different, but they both will say that a DM water will be called DM water only if the conductivity is less than 0.1 microsiemens per centimeter in the online conductivity meter. So if you do not have that, if you have 0.2, 0.3, 0.4 microsiemens of conductivity in the DM water in the online conductivity meter, that means you are actually not having technically correct DM water with you. That is the most important point which water treatment fellows will not tell you, because one is they may themselves may not be knowing, or they may be actually hiding it from you. Why I'm telling you this? Here is the chart. You can see on the screen the chart. If you have a chloride concentration in the DM water at 2 ppb level, the specific online conductivity would be 0.060. The purest water conductivity is 0.054. A water conductivity cannot go below 0.054. Remember this point. This point will be very important for you. A purest water, a water which is not having any dissolved gas, any dissolved solids, anything, that will have still a conductivity of 0.054 or resistivity of 18.8 ohms. Now here you see what is happening. If you are having 2 ppb, 2 micrograms per liter of chloride in the DM water, the specific conductivity is going to rise to 0.060. But there is one more system as per EPRI guideline, VGB guidelines, that there is one cation conductivity, which all the NTPCs and all the generally all the modern power plants, they use cation conductivity. So the cation conductivity will rise in the case where the concentration of chloride is 2 ppb. It will go from specific conductivity of 0.060 to 0.066. And when this chloride becomes 50 ppb, at that time the specific conductivity goes to 0.163. People are still happy. They are nice. Oh, I'm getting 0.2 DM water conductivity. But in fact, you are having a chance of chloride in the DM water of 50 ppb level, which will ultimately go into the drum and may get carried over to the turbines. At that time, the cation conductivity will be 0.603. So cation conductivity is one of the instruments which is very, very much important in Indian industry, and I will show you the EPRI guidelines for the systems or the boilers running below 105 kg centimeters per below 105 kg per centimeter square and above 105 kg per centimeter square. I'll talk about both the boilers and talk about the difference. But you see chloride, how does it affect? And when the chloride becomes 200, the DM water conductivity online is 0.488. We may not be knowing. We are happy with 0.5 microsiemens. Oh, our DM water is good. It is having 0.5 microsiemens of conductivity. But it may not be good. This chloride of 200 ppb may be going inside the boiler drum. The boilers are usually running more than 50 cycles. So 200 ppb or 0.2 ppm into 50 cycles will be 10 ppm inside the boiler, and 1.18% of that chloride will definitely get carried over. So you believe that your steam will have more than 10 ppb of chlorides, about 17-18 pp of chlorides, and those chlorides under phase transition zone, it is known as PTZ, where the water will try to, where the steam will try to become water during the LP stage blades when we are running at over vacuums. Over vacuums means if you are designed it to run at 0.91, if you are running at 0.92 or 0.93, then a phase transition zone will come in the LP section of the blade, and these chlorides will settle in the LP section of the blade in the root of the blades and will crack the root of the blades. There are numerous examples in India, more than 2000 examples in India where chlorides and sulfate has caused LP blade damages. Okay, similarly you can see the sulfate, if it is 2 ppb, the specific conductivity would be 0.059. If 50 ppb, the specific conductivity is 0.147. Now I made an algorithm on all these things. You know how much specific conductivity and how much cation conductivity will happen at what chloride ppb levels. But that is my own patent actually. I hold 4 patents till now. So that is one of the patents which I have, which I can share with you in because in JSW Bellary, I've made one whole system of algorithms and with regression, with predictive analytics to find out what may go wrong in my system if I go with this kind of water quality. So here you see sulfates. You can see 200 ppb sulfate can raise your cation conductivity to 1.785, and that is too high. The limit is 0.2. The limit of cation conductivity in feed water, in saturated steam and main steam is 0.2 microsiemens per centimeter, and it depends on the contamination of the anions. While phosphate also, with the increase of phosphate, the specific conductivity and cation conductivity increases, but there is a reversible reaction here. The cation conductivity actually reduces because HPO3, the hydrogen plus phosphate, that conductivity is not very high. Then carbon dioxide, it actually increases the cation conductivity at lower ppb levels at say 50 ppb. It comes from the atmosphere when you are not having caustic breathers with your DM plants, caustic breather with your DM tanks and कंडेंसेट स्टोरेज टैंक्स. यदि आपके पास कॉस्टिक ब्रीदर नहीं है कंडेंसेट स्टोरेज टैंक में या फिर डीएम स्टोरेज टैंक में, तो वहां पर कार्बन डाइऑक्साइड एटमॉस्फेयर से आसानी से अंदर चली जाती है. इट गोज इनसाइड whenever you are pushing the water, whenever you are pumping the water inside the condenser or inside the deaerator, at that time the water level goes down and the air goes inside. And when the air goes inside, you may be having balls, plastic balls inside, which you say that can prevent carbon dioxide, but it is a myth. That does not prevent carbon dioxide because it is rolling inside and a thin film of water is getting adhered. एक पतला परत जो है पानी का उस प्लास्टिक बॉल पे आ जाता है, जिसमें कि बाहर से गैस इजीली डिफ्यूज हो जाती है. Gas diffuses very easily in that thin film of water. So plastic ball does not work the purpose. It's caustic breather which you have to install. You can make it inside your plant itself. You don't have to go outside and purchase it. You can get a diagram how to make it, how big it should be, and you can make it inside your plant and you can install it. It hardly costs you 10,000 to 15,000 to make it inside your plant. If you purchase it from outside, it will cost lakhs. So it is very easy for making it. So if you are having caustic breathers, that will prevent carbon dioxide to go inside the DM water and increase the conductivity and decrease the pH, because carbon dioxide will become HCO3. HCO3 will dissolve, carbonic acid will dissolve in the water and the pH will reduce. Okay, so carbon dioxide is another contaminant. So these are the four contaminants which are very important. So, and here is the relationship. Once you get these slides, please make it convenient to have it for your people also to know what contaminants can do with your conductivities. But from all these things, the important point to note is your DM water will be called DM water only if it is having 0.1 microsiemens per centimeter of conductivity. If it is having more, that cannot be called DM water technically. Here is another chart which tells you, concentration versus the cation conductivity. If there is 16 ppb of chloride, the cation conductivity could be 0.2. Sulfate 21 ppb will cause cation conductivity of 0.2. Similarly, from acetate and formate, from where these acetate and formate can come? It can come from morpholine if you are adding in the system. People do this mistake regularly because of lack of knowledge that morpholine thermal degradation will give acetates and formates in the stream water cycle, which are actually corrosive to the stream water system. So acetates and formates are coming from your morpholine, or if you are using other cyclohexamine, or you are using say MECO or DEHA at that time also. So these also will increase the conductivity. So we will never be able to reach below 0.2 of conductivity when you are using morpholine or cyclohexamine or DEHA. So believe in simple chemistry. Your boiler water system should have only three important chemicals. One is ammonia, second is hydrazine, and third is trisodium phosphate. Hydrazine, people talk about hydrazine that is carcinogenic, but in fact, there is zero case in India of any cancer formation due to hydrazine to anybody. So when we do a RPN number for IMS or ISO 14000, at that time hydrazine has zero probability of affecting when you're using proper PPEs. Then phosphate, if it is there as 40 ppb, it can raise the cation conductivity to 0.2, and carbon dioxide 46 ppb can raise cation conductivity to 0.2. These are the reference slides for you which you can use, and you can also make algorithms like me that what could be the possibilities. Now coming to the center, the core of the training, there are two important types of treatment. One is internal and another is external. First is external, like demineralization. There could be several configuration depending on the water quality, the raw water quality available. The plants which are near the sea, they would be having desalination plant followed by second pass RO and then followed by 1 MB or maybe a train of cation, anion, NMB with degasser. Whereas the hinterland plants like those who are in Tadipatri, they may be using surface water and maybe having a conventional DM plant, or otherwise they can be having a RO plus MB or RO plus EDI. Like in Hyderabad region, most of the plants, pharmaceutical plants, in fact, they are having RO and EDI because they want ultra pure water. Even the steam water cycle also requires ultra pure water. So now the trend is going towards RO and EDI. EDI means there is also called continuous electro deionization system. We'll talk about it. Now, another point is internal treatment is by adding chemicals. So which chemicals we need to add? Only three specific, make it simple. Keep it very simple. Don't add unnecessary chemicals into the system because that has lesser positives than the negatives. The negatives of these morpholins, cyclohexamine or DEHA or MECO are higher than what it is in simple hydrazine, ammonia and TSP. So I request you to be very simple in steam water cycle chemistry. Now we go into the external water treatment. The external water treatment may be having ion exchanger, a demineralizer, or a reverse osmosis. I hope you all know how the ion exchanger work. The ion exchanger work as cations and anions separate resins are used. The cation resins will exchange cations from the water. Like cations are like if the salt is NaCl, the cation will be sodium Na and the anion will be chloride Cl. Similarly, if it is calcium carbonate, calcium will be the cation, carbonate will be the anion. So ion exchange resins are also having two types. One is cation and one is anion. Cation resin will take care of the cations. It will take the cations from the water and release hydrogen in the water. So cation is placed before anion resin beds because for exchanging anions, the anion resin will need some mineral acidity. It cannot simply exchange anions from the water when bigger cations are also available. Okay. So people ask this question many times, why cation resins are before anion resins? The cause is that anion exchanger needs mineral acidity to exchange the anions, and that is why the anions are placed after cations, and maybe we are having a degasser in between so that the anionic load as CO2 is reduced, the free CO2 is reduced. And in some plants, it's so simple that it's a reverse osmosis plant followed by MB, mixed bed. Mixed bed is also having both anions and cation beds, and or it is EDI, electrodeionization system. So before any of these are used, either ion exchange or reverse osmosis or ultrafiltration plus reverse osmosis plus MB, you need to remove all the suspended solids and color from the raw water. And that system is called pre-treatment of the water. So before the DM plant, there will be always a pre-treatment of the water through clarifiers. So those using surface water or those using sea water will always have a clarifier before the DM plant. Okay, clarifier. In clarifier, you are going through two systems. One is called coagulation and another is called flocculation. Coagulation is actually neutralizing the charges of the negatively charged colloidal particles and making them available to get agglomerated together, and flocculation is actually bridging those agglomerated particles together so that they can form a flock and settle down in the clarifier. Okay, the method of pre-treatment includes sedimentation, that is coagulation, flocculation, in the settling tank or clarifier. There may be types of clarifier. Okay, there may be conventional type of clarifier which takes about 4 hours of retention time. There may be a clarifier called HRSCC, high rate solid contact clarifier, which takes 2.5 hours of retention time. They're smaller in configuration and their settling time is good. The chemical required is lesser than the conventional clarifiers. And the third type is lamella clarifier or tube settlers, which are uh, mostly used in seawater clarification systems. And the fourth type, which has come newly, is called Clary Tube Settler. That takes only 1.5 hours of settling time. Not much monitoring is required, and you get a very good quality of water, even with lesser amount of coagulants. That is the advancement which has come in the system. So that would be followed by pressure sand filters and maybe Macron cartridge filters. Now, after we make the DM water available or we make the DM water, then deaeration is the important part for a steam water cycle. Okay, because we know oxygen causes trouble in the system in form of corrosion. Now, if I ask anyone, how does oxygen cause corrosion in the system? People may be saying that they will be forming pitting corrosion. But oxygen forms pitting corrosion only if the dissolved oxygen levels are more than 200 ppb and the water levels are in stagnant condition. In operational status, under 200 ppb, oxygen will never form pitting. It will only form hematite layer. Rather than the protective magnetite black layer, it will form reddish hematite layer in the system. So we'll talk about that also in length, because that is one of the most important uh, basics you should know, because there are two things. Another is pH. People will say, why we keep high pH? People will say that because low pH is acidic. But what happens if it is acidic? How does the metal gets corroded in the acidic system? What happens to the system? What is the temperature which governs the uh, hydrogen ion concentration? That we'll discuss. But here we are discussing the deaeration. In the deaeration, we need to remove the dissolved gases, okay, such as oxygen, carbon dioxide. Carbon dioxide can only be removed from the makeup water. Once it has come into the system, it will become ammonium carbamate, and you will never be able to remove the carbon dioxide from the deaerator. So it can only be removed when the makeup is either happening in the condenser where it is sprayed over the exhaust stream, or when it is sprayed inside the deaerator over the steam coming up. Okay, it can be removed from the makeup only. But first is we should try to stop carbon dioxide entering our system by installing small, very economical caustic breathers. But oxygen, yes, that needs to be removed. Absolutely. Now, we are talking now about deaerators, but the world has gone into membrane deaeration also. We are talking about thermal deaeration, which are of two types. One is pressure deaeration, another is vacuum deaeration. Then also there are two types. One is spray deaerator, another is your slat tray deaerators. So that depends. The performance depends on the design. But ultimately, we have to achieve what? 7 ppb of oxygen. Now, for that deaeration, we first go through mechanical deaeration. And second, we'll go through chemical deaeration. So, all natural waters will contain some amount of oxygen. The saturation of oxygen in the water at 25 degrees centigrade is about 7 ppb in the raw water. In the DM water, it goes up to 9 ppb. So removal of oxygen and carbon dioxide, they are very important. Hello, anybody wants to ask any question? Hello, any questions?
No, sir, no.
Okay, I'm getting some voice, so I thought that there may be some question. So removal of oxygen, carbon dioxide, and the other non-condensable gases, maybe sometimes in groundwater there may be H2S also, that is required to remove from the boiler feed water. for the longevity of the boiler so that corrosion should not happen. So for that, mechanical derators are used, and even after mechanical deration, we add chemical deration. Though we may not need chemical deration to that level, but a little bit of chemical, say a residual of 0.01 ppm or 10 ppb of hydrazine, would be good to create that black magnetite layer. But remember, deaeration do not remove carbon dioxide. It can remove from the makeup water only, but once the carbon dioxide has gone inside the system, ammonia will react with the carbon dioxide and it will become ammonium carbamate. And ammonium carbamate can never be removed from the steam water cycle. Then mechanical deration, as I told you that it is very much possible to get very low ppb of oxygen content from the deaerator, especially pressure deaerator. Now, in the modern times, the deaerators are designed at the outlet oxygen should be less than 7 ppb. The vacuum type deaerator can reduce, they work at about 82 degrees centigrade and can reduce the oxygen content in the water to 0.02 milligrams per liter. So vacuum pumps are there to eject the steam which is required to maintain the vacuum. And the pressure type deaerator, they work at more than 105 degrees centigrade and they can have the oxygen content in the outlet of around 5 ppb, 0.005 ppm milligram per liter. Then you may ask, why do we need chemical deaeration in that case? Yes, your question is very correct. If you say that when we are achieving the desired oxygen level in the deaerator itself, why do we need chemical control for oxygen of scavenging the oxygen or deaerating the oxygen? We may not require actually, if we are measuring in the inlet and outlet, we actually may not require. But still, to maintain that magnetite layer intact, we need say about 10 ppb only. 10 ppb is 0.010 milligram per liter or 0.010 ppm. So we may need 10 ppb or lesser just to maintain a reducing environment which is having a negative ORP. Okay, oxidation reduction potential is negative, so that the magnetite layer which is formed through Seeko's reaction is available to form inside the high temperature zones. In low temperature zones, magnetite, even if they are formed, they are not very adherent. Okay, they are loose. Like in economizer or pre-economizer zones, they are actually loose. It forms a very good adherent layer in the boiler. So a little bit of chemical would be good, but you will be surprised to know that at this moment, most of the uh, NTPCs, about 70% of NTPCs, which are having subcritical units at say 250 megawatt, around 250 megawatts, they are switching over to AVTO, where they are stopping the hydrogen dosing at all, because they know that their deaerators are capable enough to achieve the dissolved oxygen. Now, what is the good and what is the bad effect of having hydrazine or having oxygen scavenger or not having oxygen scavenger? The good part is that you may still be having some part of magnetite coming out, you'll be able to regenerate that magnetite again. Okay, the bad part is that if you do not have hydrogen in the system and suddenly there is some problem in the deaerator, you may not be able to control it. But remember, the talk about hydrogen a carcinogen, yes, it is a carcinogen, but there are no reported cases of having cancer because of hydrazine. Okay, people suffering of cancer because of hydrazine. While we know that smoking is bad, people are suffering of cancer due to smoking, but still smoking is going on, right? We do not have a single case of having cancer due to hydrazine, and thus all the bigger units like NTPC, like Adani's, like Tata's, everybody is continuing with hydrazine. They are not deviating from the simple chemistry. So I request you and your team also not to deviate from the simple chemistry which is being maintained all over the world through EPRI and VGB guidelines. Now, when we talk about this, we should also talk about the hello, somebody is actually unmuted. No, his background sound is coming. May I request him or her to please mute him or her until unless you have a question to ask. You can ask any question at any time. Now again I'm Nak ma'am, would you please mute yourself? Nak ma'am, can you please mute yourself? All right, we go back into the so steam is actually a preferred deaeration in mechanical deaeration system. Steam is pushed from the below from the spargers into the water, incoming water, so that it can remove the CO2 and O2. That is what mechanical deaeration says. CO2 can only be removed from the makeup water, not from the water which has already formed ammonium carbamate. Now, chemical deaeration, we'll see the comparison of different chemical scavengers in the next slide, and and we'll see what is the difference between the dosing levels and what are the harmful things which are available. But while the mechanical deaerators can reduce oxygen to very low levels up to 5 ppb, even trace amount of oxygen may cause corrosion damage to a system, it says. But actually you need 5 ppb of oxygen at least to form Fe3O4 magnetite, a black colored layer. So even for the reducing of the chances of having oxygen and hydrogen, which helps formation of magnetite layer, that has been added in the system, so that you have a passivation layer in the system intact. So let us see that comparison table of oxygen scavenger in the slide. Here it is. You can see hydrogen on the first number. It requires only 1 ppm as 100%. All chemicals are written as 100%. It requires only 1 ppm versus 1 ppm of dissolved oxygen. So 1 ppb versus 1 ppb of dissolved oxygen. If your mechanical deaerator is giving 5 ppb of dissolved oxygen, and if you are adding 15 ppb of 15 ppb of hydrazine, that should be enough to control all the systems. Otherwise, the hydrazine will make the magnetite layer thicker and thicker, and you will be forced to have phosphate hideouts. When the magnetite layer becomes thicker and thicker, the phosphates hides below the magnetite during high pressure operations. When the pressure drops, that phosphate comes back. So even with hydrazine, you need to dose it the minimum as required. The desired pH range is okay for our operations. The oxygen reaction rate above 82 degrees is also fair. Metal passivation strength is good. The volatility means the hydrazine coming out of the boiler water going to steam is poor, but there is always a chance of having hydrazine in the steam as well, but very less chance. Okay, the chances are very less because it converts into ammonia. If there is any residual hydrazine available, it will convert into ammonia. Okay, the thermal degradation will happen into ammonia, and ammonia is not harmful for the system. Second is carbohydrazide. People say hydrazine is carcinogenic, please use carbohydrazine instead. I'll use carbohydrazide, but you see the difference in the ppm required. Okay, there is a cost implication. Indian industries are governed by the cost implication, but there is another implication is that carbohydrazide forms carbon dioxide, which forms carbonic acid. So you will need more of ammonia to uh, react with that carbonic acid, and ultimately you will have higher conductivities than what is actually required in the steam water system. So that is what is carbohydrazide. The third one is MECO, methyl ethyl ketoenzyme. MECO requirement is 6 ppm versus 1 ppm of oxygen, so 6:1. pH range is very good, 6 to 10. It can react. It is having very good oxygen reaction rate. If you add MECO in the deaerators, you'll find your deaerators completely black. That is very sure. Excuse me. So the metal passivation strength of MECO is also good, and the volatility is also good. But there is a harm, and that harm is that it forms methyl ketones in the system. That is total organic carbon and CO2, and that will become corrosive to your system ultimately. So even still with the MECO, hydrogen is better. But if hydrogen is not available, I'll still go with MECO. Okay, then diethyl hydroxylamine, DEHA. pH range is good. The ppm required is only 3 times to the hydrazine. Metal passivation strength is fair to good. It is excellent at pressure below 14 kg per centimeter square. Above 14 kg per centimeter square, it decomposes rapidly and makes acetates and aldehydes, ultimately acetic acid. So what will happen? Your system will have acids, organic acids inside, and where you will require to add more of ammonia, and ultimately more of ammonia means you are adding more of conductivity into the system. And when your system is having copper inside your boiler water system, either in the feed water system or in the condenser, then more of ammonia will actually corrode those copper components. So my discussion, and I rest here, that hydrogen is still the best oxygen scavenger if you want to use, and I request you not to deviate from the hydrogen. Though hydrogen is not manufactured in India, but no other chemical is also manufactured in India. Okay, we import all these things from outside. Nothing is being manufactured in India. Now, our government should try and build up facilities to create hydrazine, TCC, and all those chemicals which are not being made in India, and we're always importing it either from Europe or China. Currently, we are more importing it from China because Europe is highly unstable at this moment. So this is how I want to keep in front of you the system. The last three, hydroquinone, erythrobic acid, and sodium sulfide, are for smaller boilers. Smaller boilers which are not actually used for generating power because they can only produce saturated steam. There we can use these hydroquinone, erythrobic acid, and sodium sulfide. Any question till now? We have already gone through 50 minutes of our presentation. So any questions till now?
Sir, we can, hydrogen is available in India, sir. That is
Yes.
in Kovur, in Andhra Pradesh, Kovur is there, no? That is available there.
But it
Hydrogen.
is not manufactured in India. It has actually been imported.
No, I heard that one, they are manufacturing in Kovur.
Okay, we'll find it out. Sure, we'll find it out. If it is there, then our chemicals will have their product. We'll have make in India products. We are
Yeah,
now
yes, sir.
currently importing it. Yeah. That. Thank you for this information. Any questions till now? Are you clear that why you should not deviate from hydrazine?
Yes, sir. We are clear.
Okay. Anybody else have any comment on this? Because a lot of your plants are having one drum treatment. Okay, and that one drum treatment is not having hydrazine. Otherwise, that if that one drum treatment really works, then NTPC would have also gone for that one drum treatment. Adani also would have gone for one drum treatment. Tata should have also gone for one drum treatment. Why they will come go behind? Okay, since they are using it, there is some sense of using it, and here is the sense which I'm clearly making it in front of you. That hydrazine, the requirement is less, only 1 ppm versus 1 ppm, and secondly, it does not break down into any harmful chemicals in your boiler water system. Okay. The next point is why do we need good steam water cycle chemistry? Only three things with a common agenda. Three different situations with a common agenda. First is to form a passivation layer, a protective layer, to form a proper protective passivation layer, and to protect that passivation layer during the operations, and also to protect that passivation layer during the shutdown. During the shutdown, our Indian practice is normally, we are going for wet preservation, and we are adding ammonia to raise the pH up to 9.5 and adding 200 ppm of hydrazine. But people do not know that hydrazine does not react in room temperature. Hydrazine does not react with oxygen in room temperature. It is merely a eye wash when you are doing that. The companies like JSW and JSW at Bellary and other places, what they do, even at JSL, Jindal Stainless Steel, they fill it with nitrogen completely. Okay, that preserves the boiler well. They do not have any problem after preservations. Anyway, we can discuss more about it, because the walls of some of the boilers, especially BHEL make boilers, they do not hold properly. But all the boilers which are made by Chinese, though I am not pro-Chinese, but the boilers which are made by Chinese, all their walls actually are working well and they're holding well. So all the
Sir,
yeah.
sir, at present, what we are doing, we are following same thing, sir. We are maintaining 200 ppm of hydrogen and we are keeping preserving boilers, sir.
Yeah,
When boilers are not in service, that time we are maintaining 10 pH and also 200 ppm of hydrogen. So is it?
Because you are not having a facility of nitrogen filling in the boiler.
Yes, sir. We
Number
don't
one,
have, sir.
and even there is a system. If you'll go through my book, that book is known as Practical Guide to Thermal Power Station Chemistry. It is
Okay,
also
sir.
available in soft copies. So
Okay, sir.
even when you go through the book, you will find that there are some more means of doing that. You can hot blow the boiler and keep it dry inside. If you can make it dry, it's very good. And even without that, you can add nitrate borate also. And the hydrazine and ammonia is the last option remaining. But please remember one thing: hydrazine does not react with oxygen in the room temperature. The
Yes,
reaction
yes,
rate
sir.
is insignificant. Okay.
Yes, sir.
So
Correct.
anybody having a thought that hydrogen will react with the oxygen when we are preserving is absolutely a myth.
Yes,
Okay.
correct, correct.
Okay. So
Thank
the
you.
yeah. So the basic is that if we are protecting our protective layer 24 into 7 by 365 days, will be having will not have any boiler failure or turbine failure because of the cycle chemistry. Now we'll talk about the very basic pH and dissolved oxygen. Okay, because many people, even after doing BOE, they may not be able to pinpoint the answers. Why do we keep high pH? People will say because low pH is acidic and high pH is alkaline, acidic conditions will corrode. How does the acidic pH corrode? If I do a Y-by analysis on this, then I will ask why low pH should corrode. Then mostly people will not have any answer. Few people may have. Similarly is with dissolved oxygen. Okay, now I'll take you to the real actual scenario, and it is being published by CGB long back in 1972. Okay, itself. First is these are the parameters which we are looking at in the boiler: pH, dissolved oxygen, phosphate conductivity, and one of the system which you need to incorporate into your system is after strong acid cation conductivity, also known as cation conductivity. It's merely a small cost, but it gives lot of information of the impurity in your water, in the DM water, in the feed water, in the saturated stream, and the main stream. Then we measure chlorides. It's difficult to measure chlorides below 50 ppb with common spectrophotometers. So bigger plants they install ICP, okay, inductively coupled plasmascopy, or IC, ion chromatograph. Ion chromatograph can tell about chlorides. Reactive silica we do measure, and you also be measuring in your systems. Copper, wherever there is a copper system in the feed water or copper in the condensate system, there you should measure copper. Iron, definitely you should measure, because iron should not be more than 10 ppb in the mainstream at around 105 kg per centimeter square of the pressures, and higher pressures it goes down to 5 ppb. And any increase in iron concentration will always tell you that there is some kind of corrosion still happening inside your system. So sometimes when we go into the sites, we also do measure hydrogen. We'll tell you why do we measure hydrogen in the next slides. Then alkalinity, yes, that is important, and P should be always half of M alkalinity to avoid hydroxyl alkalinity, because hydroxyl alkalinity will cause carryover and priming and foaming. Okay, so that is one. Ammonia, wherever we are having copper based systems, we should always avoid having more than 0.5 ppm of ammonia in the steam water cycle. So for that, ammonia needs to be measured. Hydrogen, the residual should be measured only in boiler, not in economizer inlet, because after just adding hydrogen in the system, after the boiler feed pump in the boiler feed pump section, the travel time from boiler feed pump section to the economizer may be in seconds, and hydrogen will still require few minutes to react. So always it should be, the residual should be checked in boiler water. Now, total organic carbon is one of the things we should start measuring. Now, you may not be having TOC analyzers in your systems, in your labs. So, it's better we start monitoring the KMNO4 number. KMNO4 number is potential permanganate number from which we can derive the total organic carbon, and that will tell us how much total organic carbon could be present in the system. Okay, that will estimate the total organic carbon. Then sodium. Why sodium? Because sodium, if it get carried over, then can cause turbine blade to crack from the top of the blade. The LP turbine blade, whenever it is cracking from the top, you will see, if you do a washing of that blade, you will find a lot of sodium present in that spot of the failure. So sodium causes stress corrosion in the turbine blades in the LP section. Then colloidal silica. Colloidal silica, why colloidal silica needs to be measured? Because colloidal silica can only be measured in the feed water. Once the water is above 130 degrees centigrade, it will slowly start converting into reactive silica. If you do it in the makeup, that will be good. How colloidal silica is measured is by measuring total silica and
Dissolved silica.
detecting reactive silica.
Dissolved silica.
Yes, correct, very correct. So total silica minus reactive silica will be colloidal silica, and there are few methods of measuring colloidal silica, total silica. One is through membrane system, passing the water through 0.45 membrane and then measuring the silica in the residual water. And the other method is dissolving the complete things into hydrogen fluoride. There is ASTM procedure on that. And the third one is a easier one. You are using platinum crucible in the coal labs normally. Take a fresh new platinum crucible, fill in 10 ml of your 10 to 15 ml of your water, which you want to check total silica. Add a pinch of silica-free sodium carbonate. Boil it to half and then make it up with silica-free water if you are having. Otherwise, with that half, you measure the silica levels with the half portion of that chemicals. You'll find what is that. Even you can do it in a steel glass of say 100 ml. You can reduce it to 50 ml and then you can check the total silica. But you need silica-free sodium carbonate to be added into it to raise its pH a little bit, because silica solubilizes in higher pH. Okay, silica precipitates in lower pH and solubilizes in higher pH. Then what are the common sampling points? This makeup water, feed water after deaerator, the boiler water, the saturated steam, the main steam, and the condensate. Okay, we all know about this, right? Anything in addition? In addition, we may do, LP heaters, HP heaters. We may do some sampling of the extraction lines using a mobile cooler. Using a mobile cooler, we can do sampling of extraction lines, HP extraction, LP extraction, which is going to deaerator. That sampling we can do with a mobile cooler and a sampling system. That is always there. But these are the common sampling points we use. And to analyze, you all know that you should have a SWAS system available. SWAS. SWAS means Steam Water Analysis System. This should be available in your plants always, because you cannot always depend on a time of sample, maybe with a human error of sampling, maybe with a contaminated bottle of sampling, maybe a human error at the lab, maybe a human error with the instrument calibration. You cannot depend on that. You should need something online where you should be always be aware, okay, my operations are going good. That is pH. It should be mostly online. Even in condensate also, it should be online. If it is not there, it's okay, but you should be having all the things online. Dissolved oxygen you should have always online in the feed water and condensate, and you should have a cross-checking methodology of dissolved oxygen with a handheld oxygen analyzer. Sometimes it is known as Orbisphere, and there are other makes also. So that you take to the position of sampling, plug it into the tubes, and check the sample dissolved oxygen, and tell C&I that your dissolved oxygen meter is correct or incorrect. If you need some calibration, all that. Dissolved oxygen is important. pH is important. Phosphate in boiler water, you can check at lab only. You can have online meters, but those are very costlier one. Smaller units may not need online measurement of phosphate. But phosphate, as per the newer guidelines, have a lower levels of the limits. Now, below 105 kg per centimeter square, the phosphate level maximum is 3.6. People were maintaining 5, 6, 7, 8, 9, 10. That is wrong. That phosphate will cause acid phosphate corrosion. So high phosphate. So reduce that phosphate levels. Below 105 kg per centimeter square of operating pressure, you may have maximum of 3.6 ppm of phosphate, and above 105 kg per centimeter square, you may have only 1.5 ppm of phosphate. That is the newer, the uh, current guidelines all over the world, which NTPC and giant power plants are maintaining. Okay, conductivity, mostly it should be online. Even the condensate also it should be online. But downstream strong acid cation conductivity, which is also known as cation conductivity, should always be online in the condensate. Okay, that tells us if there is a condenser leakage. If you are having air cooled condenser, you may require a degassed cation conductivity column as well, which will tell you the difference between a CO2 free water and with CO2 water, because always your air cooled condensers will try to take CO2, because it will have, in any case, it will have some of the places where air is getting ingressed in the system, and that is why the carbon dioxide will increase in the system. So you should need a degassed cation conductivity system at the condensate storage tank level, wherever you are having air cooled condenser. ACC guidelines of EPRI also mentions the same. Even when it is air cooled condenser, your pH levels goes as high as 9.8 to 10 as per the EPRI guidelines. Okay, it should not be 9 or plus minus 2. Okay, because condensate in air cooled condenser may absorb lot of CO2 from the atmosphere. Then chlorides, you should check in lab. Reactive silica, it could be online, or you can have it offline also. You must maintain a reactive silica online at least in the boiler water and mainstream. Okay, two channel reactive silica analyzer are available in the market. You can have two channel. Every hour you can measure both of them with 30 minutes interval. Okay, so boiler water and mainstream, both of them should have reactive silica analyzer, which will tell you what is happening within a system, how much silica is getting accumulated in the boiler drum and how much is getting sublimed or evaporated with the steam. Okay, carried over with the steam. Copper, if you are having a copper system in the feed water system of a boiler or in the condenser, then you must check copper in the lab. Iron, you should check in the lab regularly, and there should be no lagging in iron measurement. Every week you should have at least one sample checked in the lab. You may decide your dates as per your requirement. Okay, that should be also total iron measurement. It should not be dissolved iron measurement. It should be total iron measurement, and total iron measurement requires a very simple step before the dissolved iron measurement is to add 1:1 HCl and digest it to half. Okay, digest means boil it to half, and then you go with the normal procedure of measuring total iron, normal pressure of normal procedure of measuring iron. Thus, just digestion is the method which you are adding in. Okay, then alkalinity, you should check in lab. Ammonia, you should check online and also in lab. But online is not very much necessary. Even if a lab analysis, if it tells it is within the limits of 0.5 having copper in a mixed metallurgy system, then it's okay. Otherwise, if you are having all ferrous systems, all with iron, then you may have ammonia up to 1 ppm, 1.2 ppm. That does not harm anyway. Hydrazine should, there are online analyzers, but you may select to go with the lab analysis. And hydrazine ppb levels in the boiler water, not in feed water, in the boiler water should be 10 ppbs. Total organic carbon, if you're not having KMNO4 number method, you can ask me. I will supply you the KMNO4 testing procedure, and I can even supply you the whole ASTM testing procedures for you for a power plant. So the TOC analysis, like if you do not have a TOC analyzer, you can do it with KMNO4 number, and you can do it for all the samples in the lab. Correlate silica also you should check in makeup water in the lab. Now, what is the significance of pH and dissolved oxygen? We are coming to this. So pH, what is pH? As it is written here in the end, pH is negative logarithm of hydrogen ion concentration. That is how in Three Idiot picture, the movie called Three Idiot, that is how Chatur will say that it is a negative log of hydrogen ion concentration. How many people understands that? Not all, right? Maybe some of the engineers will understand negative log. They will understand hydrogen ion concentration, but they will not know what is the unit in that measurement. So I'll take you to the basics. Water is actually a very weak electrolyte. Okay, that is why it is having a conductivity of 0.054. Conductivity cannot go to 000 of water. Okay, it is slightly ionized always, so it tends to separate out as H2 and O2 within the water system. And at 25 degrees centigrade, if the water pH is 7 in the pure water, the H ions and OH ions both will have 1 into 10 to the power minus 7 gram ion per dm cube of each of them. Okay, hydrogen will be 1 into 10 to the power minus 7 gram ion per dm cube, and hydroxyl ion also will be 1 into 10 to the power minus 7 per decameter cube. Okay, so the dissociation constant means the multiplication of total 1 into 10 to the power minus 7 into 1 into 10 to the power minus 7 would be 1 into 10 to the power 14. That is why the pH range is 1 to 14. Now here the important thing to understand that because it is a negative log of hydrogen ion concentration, the increase in hydrogen ion concentration as the 10 to the power minus 7 becomes 10 to the power 6 or 10 to the power 5, the hydrogen ion is increasing, and the OH ions in that respect will decrease from 10 to the power minus 7 to 10 to the power 8 to 10 to the power 8 to minus 10 to the power 9 as the pH decreases. So when the pH decreases, hydrogen ion concentration increases. Okay, it becomes minus 6, minus 5, minus 4, like that. So that is why we call it pH, and when pH is low, that means hydrogen ion concentration is going high, and one pH reduction means 10-fold reduction of hydrogen ion concentration, or one pH increase means 10-fold increase in hydroxyl ion concentration. Okay. And when one increases, the other decreases because the dissociation constant remains same 1 into 10 to the power minus 14. So the pH 6 means 1 to the power 10 to the power minus 6 and pH 8 means 1 into 10 to the power minus 8. Now, which is bigger? Higher concentration? Definitely 10 to the power minus 6 is the higher concentration than 10 to the power minus 8. Right? And the scale is logarithmic. So decrease in pH value by 1 unit corresponds to 10-fold increase in hydrogen ion concentration. And what is the unit of this? Gram ion per dm cube. Okay. Now let us understand the corrosion cell, and from in the corrosion cell we'll understand the implication of hydrogen and also oxygen into this. Okay, hydrogen means we'll understand the implication of pH here. The corrosion of metal is essentially an electrochemical cell formation where there'll be one anode and one cathode formation. And let us consider Daniel cell where zinc is there and copper electrode is there. Both electrodes are there. Zinc becomes negative electrode and anode. Zinc becomes anode and copper becomes cathode, and there is a copper sulfate solution below, and here is zinc sulfate solution. And this cell starts working. It's not polarized, it's depolarized. Okay, it starts working. At that time, there will be one anodic reaction where the zinc will be coming out in the solution, and there will be a cathodic reaction in this Daniel cell where the copper will deposit on this cathode from the copper sulfate solution, and there will be electron flow, and wherever there is an electron flow there will be some current generation, right? This is the Daniel cell. Now in this Daniel cell we are having two reaction rates. One is anodic reaction rate, which is zinc minus 2 electron giving zinc 2 plus in the solution. That means zinc is corroding because of its low electronegativity, and the electron is traveling from the outer path to the cathode. In the cathode, the copper from the solution and the two electrons in that cathode, which is traveling from anode, the two electrons plus the copper from copper sulfate solution will be deposited on the cathode. That is cathodic reaction. And remember, in any corrosion cell and any electrochemical cell, anodic reaction will be equal to cathodic reaction rate. Rate of reaction of anode and rate of reaction of cathode will be similar. You reduce any of that, you will have reduction in corrosion. Okay, either you replace the zinc electrode with something else which is not corrosive, or else you remove that copper sulfate and copper, but still some you have to stop the cathodic reaction, because it may not be cathodic reaction may not be same always, it will change always. Okay, now if I replace the zinc sulfate solution, okay, with common NaCl or NaPO4, okay, and I replace that zinc electrode with iron, then what will happen? I will replace that zinc with iron, I'll replace that solution. Now what will happen? The previously seen anodic reaction will still be same. Iron will be coming out. Iron minus 2 electron giving Fe2 plus in the solution will be there until we have a control on pH and dissolved oxygen. And here comes the importance of pH. Why do we need higher pH in the boiler? And here comes the importance of why do we need lower dissolved oxygen in the boilers. Now, in this case, we see the anodic reaction, Fe minus 2 electron giving Fe2 plus oxidation. the cathodic reaction as seen earlier in Daniel cell will not be there because the copper is negligible in the solution. Copper will not deposit. The remaining cations available is sodium, hydrogen, and the iron which is coming out, which can form cathodic reaction. But in this case, sodium cannot be deposited as it requires very higher potential than that was with zinc to attain that deposition tendency on that copper electrode or the cathode. The sodium, normally sodium does not form very hard deposits anywhere. Okay, sodium deposition is very difficult because it requires very high potential. Then iron deposition, iron coming out and depositing at another place will imply that the cell is in equilibrium, and then it is not possible. The system will be polarized. Therefore, one cathodic reaction which is possible is hydrogen ion. From where this hydrogen ion has come is due to the pH. Okay. Somebody is unmuting in between. Is this Umesh Babu? Umesh Babu, can you mute yourself? Or you want to say something? Okay. So now for any electrochemical cell to complete, you need both anodic and cathodic reactions in place. Like in Daniel cell, you had both zinc and copper as anodic reaction and cathodic reaction. Zinc giving 2 electrons and dissolving inside the solution as zinc 2 plus was the anodic reaction, that was corrosion, and copper attaining copper from the copper sulfate solution, that was the cathodic reaction. Now when we have removed the zinc electrode, replaced the zinc electrode with the iron electrode, okay, iron, and we have removed the copper sulfate solution with common NaCl or NaPO4, then in this solution we have copper as electrode or a cathode maybe of higher electronegativity, a lower negativity of iron which is available, okay, as anode, and there is a common solution, say NaCl or Na3PO4 or that kind of electrolyte, any electrolyte. Then also the anodic reaction may happen, okay, Fe minus 2 electron giving Fe2 plus may happen even if the copper is not there to get deposited on the cell, because there will be some other cathodic reaction which will be assisting it. So let us find out what are the cathodic reactions possible. The one cathodic reaction which could have been there if sodium had a lesser potential to deposit. But sodium cannot deposit as it is having a lesser potential, very higher potential to deposit. Fe deposition will imply that this cell is in equilibrium, is polarized, and the electron will not flow. Okay, so Fe deposition is also not possible. So what is possible? The possible is the availability of hydrogen ion in the system, and the hydrogen ion from where it is coming? It's coming from the pH of the solution. And from where the hydrogen ion is coming is from pH of the solution, and pH means negative log of hydrogen ion concentration. That is a scientific sentence. Real common sense sentences, the hydrogen concentration is higher whenever the pH is lower. So when we maintain a pH of 9 or 10, the concentration of hydrogen ion is lower. So when the concentration of hydrogen ion is lower, this cathodic reaction which may have happened, 2 hydrogen plus the 2 electron traveling from here, evolution of 2 hydrogen hydrogen gas from the system as a cathodic reaction could be avoided at pH 9 to 10, this cathodic reaction could be avoided. Then you will say that why we should not go to pH higher than 10 or 11, because iron is an amphoteric metal, like aluminium is also an amphoteric metal. These both metals, iron and aluminium, they corrode both in high pH and also in low pH. So we cannot maintain very high pH as well, and we cannot maintain very low pH. But we can maintain an optimum pH of 9 to 10, between 9 to 10, but we will precisely tell you how much to maintain. That can reduce the propensity, that can reduce the possibility of this cathodic reaction. And since it is interrelated, the cathodic reaction rate and anodic reaction rates are interrelated. Thus, the reduction in the cathodic reaction rate will always reduce the aforesaid anodic reaction rate. Okay, so if I reduce this reaction rate, I will automatically reduce this reaction rate. And remember one thing, corrosion in any system, maybe it's cooling water or anything, it is always an electrochemical cell formation. Okay, so this anodic and cathodic reaction will happen. We have to retard one of them to get rid of the corrosion. Next possible cathodic reaction, when I make an alkaline solution, okay, then the next possible reaction is oxygen. The dissolved oxygen reacting with 2 moles of water and giving 2 hydroxyl ion in the system is the cathodic reaction which is possible in the alkaline solutions having dissolved oxygens in the system. And that is why we do reduce the dissolved oxygen, because we want to contain or reduce this cathodic reaction rate as well to reduce this corrosion anodic reaction rate. I hope now it is clear in front of you that by reducing the cathodic reaction rate of hydrogen ion converting into hydrogen gas and oxygen, dissolved oxygen converting into hydroxyl ion, reducing these cathodic reaction rate, we are now able to reduce the corrosion rate of iron within the boiler system. Is it okay with you to understand, or you want to deep dive into it more? Do you have any question here? Hello? Was this gulpable? Was this okay with you to understand?
Okay, sir. Okay.
Has everybody understood this thing, or they have some questions still? Or you want to go through the slides later and then come back to me? Anybody else wants to tell anything? There are 35 participants plus HR in this meeting. Now, whenever people were asking you that what was the cause of why do you keep high pH in the boiler water and why do you keep lower DO in the boiler water, I hope you all will be able to answer that you want to reduce the cathodic reaction rate which causes the anodic reaction rate of corrosion. By reducing oxygen, you are reducing the cathodic reaction rate of formation of hydroxyl ion, and by reducing hydrogen, you want to reduce the rate of cathodic reaction of hydrogen gas formation. Right? So is it clear to everybody? Any question from anybody?
That's okay, sir.
Okay, that's great. So now we come to phosphate. Now what happens when we add ammonia into the water to raise the pH? The water pH will be raised. But when when the water is boiled, at that time, due to the partition coefficient of ammonia being 10 is to 1, 10 part of this ammonia will go with the steam and only one part of the ammonia will remain in the water. Thus, in the drum at 50% level and below, the water having only ammonia will have lower pH than the steam pH. To increase the pH in the water levels while boiling the water, we need to add some of the chemical agent which are non-volatile in nature, okay, which are called solid alkalizing agent. Now, earlier days we used to use sodium hydroxide NaOH. Even there are still some boilers in Europe, America, Canada, Australia, which are still using very controlled level of sodium hydroxide to raise the boiler water pH. But mostly the bigger power plants has converted them into phosphate treatment. There was a time when we used to talk about coordinate phosphate treatment, congruent phosphate treatment, and all, but now everything is obsolete, absolutely obsolete. Now only one phosphate treatment is known, and that is known as PT, phosphate treatment only, where we only add trisodium phosphate. There is no other addition of chemical, no disodium phosphate, no monosodium phosphate, nothing. You need to maintain a molar ratio of sodium is to phosphate as 3 is to 1. That is all. And even the phosphate concentrations has been lowered in the boiler water to maintain the pH. I will take you through those slides also, which are the EPRI guidelines and also the VGB managed systems guidelines, where the phosphate levels are quite low. Now, when we were using sodium hydroxide, at that time we were having two big problems. One is localized concentration of sodium hydroxide was increasing and causing caustic gouging. It was causing caustic gouging. Caustic gouging was a kind of bathtub ring formation or a localized pit or a larger ring eating away of the metal from a place where the caustic concentration was localizedly high. At the place where the caustic is high, there we were having a problem of caustic gouging. And the other problem we were having was caustic embrittlement, where the caustic sodium from the caustic was causing cracking of the metal surface. Caustic embrittlement is brittling the metal surface and causing a crack in the metal surface. So we were facing two kinds of problem. Then in the attempt to combat that, we started using sodium phosphates, and we saw that the sodium phosphate is truly better for our system. So taking an example of trisodium phosphate, which is currently being recommended and currently being used, we'll say that trisodium phosphate plus water will make disodium hydrogen phosphate plus NaOH, which will increase the pH, and then that disodium hydrogen phosphate plus 2 moles of water will make monosodium hydrogen phosphate that you measure as phosphate in the water plus NaOH. So in both the reactions, the pH is getting increased, right? And NaOH is coming out. But the very nice part is that at a pH of around 10.3, it acts as a buffer. And rather than moving towards the right, the reaction, it reverts back to the left at pH around 10.3. This is the difference between sodium phosphate or the other source of caustic, that this reverts back to this original. But the higher phosphates levels like in lower than 105 kg per centimeter square pressure boilers, if the phosphate is maintained above 3.6 ppm, or at 100 more than 105 kg per centimeter square boilers, if you're maintaining phosphate above 1.5 ppm, then this phosphate along with the water will go beneath the protective layer, beneath the magnetite layer, and will form merisite, and that merisite will form acid phosphate corrosion that will look alike uh, bathtub ring formation, or it will be a railroad track pattern, and it will be more in the rifle tube sections. So if the in this case, if the acid appears in the boiler in any case due to condenser leaks or due to any other thing, or even formation of uh, more of the other acids, then like chloride, if it is there in the boiler water, what will happen? Chloride will form FeCl3. FeCl3 will dissociate into FeOH and HCl. The acid will appear. At that time, NaOH can react with that acid and neutralize. And if more hydroxide is there in the water, then it will try to revert back into disodium hydrogen phosphate and then into trisodium phosphate. This is the big, good part of phosphate, and the bad part of phosphate is we can't have much in the system. We have to reduce it to a level. Now, conductivity, as I told you, purest water conductivity is 0.054. Has anybody told you this before? Maybe you find out in Google and find it out. And DM water will be DM water. As per EPRI, it is 0.1 microsiemens per centimeter, while VGB Germany says is 0.8 microsiemens per centimeter. Conductivity is a measurement of electric conductance. 1 upon conductivity is equal to resistivity. So purest water will always have resistivity. Electrical current will not be able to pass through pure water. So conductivity will contribute through the dissolved solids, though people measure TDS through conductivity. They said conductivity into 0.64 is equal to TDS. But that is always not true, because in boiler water systems you have ammonia and hydrazine, which are volatile, which are actually not solids, but conductivity is being imparted by ammonia and hydrazine. So that is not always true. But yes, gases will contribute to the conductivity, and conductivity means the corrosion reaction will be higher because conductivity will be there in the electrolyte. In the cell, electrochemical cell, anode, cathode, outer metal connection, and beneath that there will be electrolyte. If the electrolyte conductivity is higher, then the current flow will be higher. Then downstream acid cation conductivity. It is actually nothing but a vessel containing your SAC resin, strong acid cation resin, through which the steam or water cycle samples are passed, so that the cations and ammonia and hydrazine are taken away by those resins, and you are getting a conductivity after passing the cation conductivity, which will be having some mineral acids. So if there are no anions available in the water, and if the water is not contaminated from external sources, like your chemicals could be contaminated, your ammonia could be contaminated, your hydrazine could be contaminated, your trisodium phosphate could be contaminated. In those cases, some anions will appear, and if there is some anion, then definitely the cation conductivity will be higher than the limit. Cation conductivity limit should be 0.2 microsiemens per centimeter in the system, both in pressures lower than 105 kg per centimeter square or pressures more than 105 kg per centimeter square. Believe me, there is nothing called low pressure, medium pressure, and high pressure boilers. There is only two phenomena: low pressure boiler or high pressure boiler. And low pressure boilers are actually termed as the boilers which are lesser than 10 kg per centimeter square. Otherwise, all others are high pressure boilers. In high pressure boilers, there are two categories. One is above 105 kg per centimeter square, and another is less than 105 kg per centimeter square. So more than or less than 105 is the point. Then another point will come at 225 kg per centimeter square, where the critical thing will appear. So this is the cation conductivity column, also known as CAAC, conductivity after cation exchange. We measure conductivity after these columns. It will tell you the low levels of anion contamination like chlorides, sulfates, and other things. It will increase the conductivity levels whenever chlorides and sulfates will appear in the stream or the water samples. There are now color changing resins also available to fill up these cation conductivity columns. Once you have filled it up with a regenerated resin as violet or black, then upon exhaustion it will become red, so that you can change the resin at the time of need. Otherwise, you will be having an ambiguity whether my resin is bad or the sample is bad. Okay, to avoid the ambiguity, you will need a color indicating resin in the system. Now, chlorides. As I told you, the chlorides will not become HCl directly. It will first attack iron, it will become FeCl3, then FeCl3 plus 2H2O will give FeOOH plus 3HCl, and then this HCl will again react with the iron and form FeCl2 plus H2. And this is the worst part, because presence of chloride is cyclic. You can't stop corrosion when the chlorides are present in higher quantum in the boiler steam water cycle. So though Germany and European guidelines says you should have zero or nil chloride in the system, but actually the water chemistry available in India specialty cannot say that we will have zero chlorides. European may have, because it is all snow or it is all glaciers which are melting and coming out, so they may be devoid of chlorides. But in India, since we are using surface water, our rivers are having chlorides, our groundwaters are having chlorides. We cannot avoid chlorides in India, so we follow EPRI guidelines in this case, having 2 ppb to 5 ppb, 2 micrograms per liter to 5 micrograms per liter. Remember, ppb divided by 1000 is ppm. Okay, so ppm into 1000 is ppb. So micrograms per liter is too low level to be measured also in our labs, chlorides, but still we can try in our spectrophotometer to make a graph of such a low level. It comes from bad quality of DM water, one, and it has shown in many of the plants in India where people are very happily recording 0.3, 0.4, 0.5 conductivity of the DM water and happily living, but actually chlorides are going inside and boiler tubes are getting affected, the corrosion, and the boiler life is reducing. NTPC and all, they keep very close watch on chlorides. NTPC, Tata Power, Adani Power, LPGCL, even Semcop in Nellore, all these plants, they keep very close watch on this chloride levels. Then it can come through your impure ammonia, hydrazine, or even it can come through your TSPs, trisodium phosphates. It can come through your condenser leak, it can remain in your system for a longer period near the backing rings, and chloride will crack the turbine blade from the root, initiating a pit formation. While sodium will crack the turbine blade from the top section, okay, due to stress corrosion cracking. Okay, it can also form cracks in superheaters. So silica could, now we come to reactive silica. Silica could deposit in the turbine blades, but it will never crack the turbine blades. Okay, silica can only do a slight disalignment, may increase your steam consumptions per megawatt generation and the loss of output generation capacity because silica is having significantly higher partition coefficient at pH 9, 1.25% of the boiler water silica will anyway get carried over with the steam, and at pH 10 it will be 1.02% of boiler water silica which will get carried over in the steam. But silica is not so harmful than the chloride, sulfates and sodium. Sodium chloride and sulfates are very harmful for the turbine blades. Silica is actually lesser harmful. You in any shutdowns in 2 years, in 4 years, you do have glass bead blasting. Okay, that removes that silica scale from the turbine blade, so you can come back to your original generation capacity. But once the turbine blade is cracked and dismantled, you will have a longer shutdown period and longer time to repair and come back to its original position, because there will be a resonation check also after your turbine blade replacement. Turbine blade replacement is not a small and simple case. Turbine blade replacement itself is a huge task because turbines are very sensitive to resonance as well. Then we come to the colloidal silica part. Colloidal silica, as I told you, it converts into reactive silica above 130 degrees centigrade. This is called colloidal silica or non-reactive silica because we cannot simply measure it through our normal procedure of molybdenum, uh, adding acidified molybdates, AAM, ammonium molybdate, acidified ammonium molybdate, because it does not react with acidified ammonium molybdate. We have to digest it in presence of high pH to get it converted into colloidal silica. Even we can do the same thing of boiler. We can add very pure ammonia and digest it, but ammonia in our digestion system, ammonia will escape in the atmosphere. That is why I said silica free sodium carbonate addition. Okay, you can add silica free sodium phosphate, but sodium phosphate will again interfere in the silica estimations. So it's better to use silica free sodium carbonates. Colloidal silica is mostly polymeric. Okay, in cooling water system you will see that, I'm just deviating from the boiler water system. Cooling water system, you will see that silica COCs are always lower than magnesium COC or calcium COC. Calcium cycles of concentration and magnesium cycles of concentration. Silica cycles of concentrations are always lower than magnesium and calcium. Why? Because it polymerizes inside the cooling water system, and that is why you can't, because you are not checking total silica, you won't be able to know the actual silica COC. Okay, colloidal silica cannot be removed by ion exchanger and it can be removed by membrane technologies, but colloidal silica can be removed up to 70% in the clarifier using dolomitic lime or dolomite or magnesium oxide. But all these three systems, dosing is bit difficult because of the jamming of dosing pumps. So a proper mixing, a good dosing pump, and or a gravitational dosing may help. So colloidal silica can be reduced in the clarifier itself up to 70%. Now, total organic carbon. Why it has uh, been mentioned? Why total organic carbon to be tested? Because number one, it is non-ionic. It does not contribute to the conductivity, and it does not get removed through the resin. Rather, it fouls the anion resin. Second, it breaks down at the boiler temperature and contributes to the undesired conductivity. And also, it liberates chlorides in the boiler water. Okay, the simple case is when, say, humic acid or fluvic acid as total organic carbon are present in the surface water, river water, they are chlorinated, they become trihalomethanes. Trihalomethanes, THMS. So trihalomethanes are like chloroforms, okay, CHCl3. So CHCl3 chloroform will not have any conductivity, any specific conductivity, will be zero. It will pass through the resin bed without affecting the conductivity of the system. But when it goes into the boiler, it will convert and liberate chloride ions, lot of chloride ions. So this is the point of problem which I found recently in Bhatinda refinery also, and that problem was solved after finding it out that we are getting chlorides in the boiler water when we check chlorides, and that chloride is actually not getting detected in the feed water, it is only getting detected in the boiler. So we started measuring with the proper system with in the DM plant itself, in the DM tank itself, by digesting the water, and we were started getting higher chlorides. So there were chloroform in the water, though the conductivity was 0.08, but there was chloroform in the water. So that was causing a lot of chloride ions getting liberated in the boiler water. So I'm in the training session, by the time I'm giving the training, I'm also telling you some of the cases which I have faced and I have seen in different places, and just informing you that this could be one of the problem, this could be another problem, this could be third problem. Likewise, chemical addition, boiler design, so many things are there which I might have seen around 600 boilers till now since I've started my company, and every boiler is having some or other issue in the steam water cycle chemistry. Now, copper iron alkalinity. Copper indicates corrosion of copper if you are having copper or copper alloys in the steam water cycle. Iron will be having a baseline of say 0.01 or 0.05 ppm, and if it is higher in the steam or feed water or boiler water, then it will indicate corrosion. Then you must check why corrosion is happening inside. And we measure hydrogen gas also in the water. We have learned this thing from Germany to measure the hydrogen gas in the water, so that we know what is the corrosion propensity in the water. Okay, though the pH is high, if the hydrogen gas is getting liberated, that means there are presence of some anions which are causing some corrosion inside. Now coming to alkalinity, we say that P should be always less than half M to avoid the presence of OH alkalinity which causes carryover. So when P is less than half M, only carbonate and bicarbonate alkalinities are present. However, here also this CO2 alkalinities can decompose into carbonic acid, but not much. Ammonia, it is a neutralizing carbonic acid, okay, and it neutralizes carbonic acid, that whatever CO2 comes into the system without getting removed, it reacts with ammonia and it will become ammonium carbamate. And ammonium carbamate cannot be removed through the deaerator because it defeats the Henry's law. Okay, ammonium carbamate defeats the Henry's law. Henry's law is not applicable on ammonium carbamate, though it may be a volatile thing, but it remains in the water only. It does not get liberated with the temperature. Okay, ammonia is a volatile alkalinity booster. You should not use morpholin in any case. The disadvantage is only to the copper solutions, the copper systems, the systems which are having copper or copper alloys. There, the pH of more than 9.5 and in presence of high DO, the copper could corrode. With hydrazine, there are all advantages. It is said that it is carcinogenic, but there is not a single reported case in India that anybody has suffered cancer due to hydrazine. If there is a report you find anywhere, please share it to me. Okay, I will go through, because I believe, NTPC believe, Adani believes, Tata believes, JSW believes, America believes, Australia believes, Japanese believes that hydrazine is the best option of oxygen scavenger. The next option is MECO. So why should we not use ammonia? We should not use ammonia because, we should not use morpholin. I'm sorry, and for the slip of tongue, we should not use morpholin in any case, because morpholin degrades into organic acids like acetates, formates, glycolates, and propionates. Okay, the thermal degradation product will be always an organic acid. Number one. Number two is its capacity to neutralize carbon dioxide. Ammonia can neutralize 2.59 ppm of carbon dioxide, while morpholin can only neutralize 0.5 ppm of carbon dioxide. So there is a cost implication as well due to the consumption. While pH adjustment, you'll see 0.5 ppm of ammonia can take you to 9.2 pH. In the case of morpholin, 8 ppm of morpholin would be required to go to the pH of 9.2. So ammonia has all the disadvantages required. But still, few people do not understand. Ammonia is 25% versus morpholin as 100%. You see here, 9 pH can be attained by 5.54 ppm of morpholin, while ammonia 25% would be required only 1.02 ppm in carbon dioxide free water. And even if it is carbon dioxide with carbon dioxide water, then also the neutralizing capacity is very high with ammonia. So it will be required 1/5 of the morpholin consumption, or maybe 1/6. So ammonia is always a better choice than morpholin. Now we come to the boiler corrosion cause and effect diagram, and one is oxygen pitting. Remember, oxygen pitting will only happen when you have stagnant oxygen rich water in the boiler for a longer period, more than 7 days. Otherwise, oxygen pitting will occur higher than 200 ppb of oxygen within the operating system. Next is poor pH control. Poor pH control can always give to hydrogen embrittlement or hydrogen damage in the boiler. Lower pH will have more hydrogen. One is that cathodic reaction will continue to happen, hydrogen reacting with two hydrogen reacting with the electron and becoming hydrogen gas. That cathodic reaction will still happen. The another reaction which happens is the hydrogen will react with the carbon in the steel and will become methane, CH3. Okay, CH4 will become methane, and the methane will get liberated, leaving the leaving that steel, leaving that iron, and the iron will become brittle. When you remove the carbon from the iron, a lesser percentage of carbon is there, then it will become brittle, like what has happened with Titanic. No, there was lesser percentage of carbon, that is why it was brittle rather than getting impacted and getting impeachment. It cracked after hitting the iceberg. Similarly, in the boiler water, when you have lower pH, at that time that pH will actually make your iron brittle by reacting with the carbon in the iron, making it converting into methane, and your iron, when it becomes brittle, will have hydrogen failures, hydrogen damages, hydrogen embrittlement, where you will see window opening or flap opening kind of thing happening inside. Okay, then deposition or under deposition can also cause corrosion, which may be due to poor feed corrosion, feed chemical, poor feed chemicals, or iron corroding and coming into a low flow area and depositing, or condensate is getting contaminated, or poor external treatment means your DM water is not good to go with. So, with all those conditions, yes, your boiler water corrosion can happen. And then the stress corrosion cracking. Stress corrosion cracking can happen only importantly in two cases. One is in presence of chlorides, and second is in presence of sodium, if it is due to boiler water uh, chemistry. If it is not due to boiler water chemistry, certainly corrosion fatigue is one of the thing which can do the stress corrosion cracking. Okay, all that there are there in the 37 mechanism which has been devised by, or which has been published by EPRI. Okay, so we can find out them in some other training session. Here is the BHEL which they have given earlier. Okay, so BHEL in the year 2004 they have given this diagram, this chart. Okay, ST overheat means short term overheat, LT overheat, creep, stress corrosion, and there is one water side corrosion is there. Caustic corrosion was mentioned, hydrogen damage was mentioned, pitting was mentioned, and there was one chemical exclusion. While now EPR has come out with 37 mechanisms, and in that 37 mechanisms, 10 are particularly related to water. Rest 27 are because of the other reasons. To find out the other reasons, connect me sometimes some other time. I will let you know more about the boiler tube failures. I have already given one training session of boiler tube failures at your Vikram cement plant about 3 years back. So this is a typical decision tree to assist you for the preservation. The first question asked for the decision tree is, will preservation exceed 7 days? If you say yes, then can water boiler be emptied? If you say yes, can boiler be dried? If you even say yes, then the best option is to go with blow down at 8 kg pressure. Okay, hot blow down at 8 kg pressure through the bottom ring header. Now, if you say that my preservation will not exceed 7 days, okay, can pressure be released? You say no, then inject 30 ppm of hydrazine and maintain a higher pH 9 to 9.5, that will be okay. If pressure can be released, is nitrogen available? You say yes, then you fill it with nitrogen. If say no, you do not have nitrogen, then inject again 30 ppm hydrazine and maintain pH of 9.5, 9 to 9.5. And this is what people are finding more easier to take. Okay. Now, this is for 7 days. For more than that, if the boiler cannot be emptied out, add a mixture of 10 ppm of ammonia and 200 ppm of hydrazine and maintain. And this is another thing which our wet preservation is taking in India. While we all are scientists, we all know, we professionals are more or less scientists. So we all know that hydrogen is going to have insignificant reaction rate with oxygen at room temperature, but we still add hydrogen and maintain hydrogen and check hydrogen during preservations. It's an irony. So can boiler be emptied? Boiler cannot be emptied. No. Then if nitrogen is available, then fill with nitrogen. Otherwise, again you go with the same phenomena. So ultimately, what is happening in India? We are only attaching with these hydrogen and ammonia. We think that chemicals will do miracles. Chemicals can't do miracles.
Sir,
People's mind has to do miracles.
sir, at present we are following same this thing. One of the chemical suppliers suggested us to replace Deha. Deha works out at ordinary room temperature also. So for preservation purpose, we can use Deha. For running purpose, you can use hydrogen. They have suggested like that, sir. What do you say for this?
Now, actually, the problem with Deha is, having undesired organics in the water. You see here acetates and acetaldehydes. So those are undesired.
Okay, I admit that one, sir. For only for preservation purpose, I am telling you, sir.
The
So can we
preservation
use
purpose, you can add sodium sulfite. Now that acts very fast
sodium sulfate, sir? Okay, okay.
because the reaction rate of DEHA is only it's good, but it may not be. It is above 82 degrees centigrade. But sodium sulfite is the only chemical which reacts at the room temperature. There is no other chemical which reacts with oxygen at the room temperature. Okay, that is why I am saying. I hope you understand.
How much we have to maintain, sir? For sodium, if it is sodium sulfate?
If you can measure the dissolved oxygen, just
No, for preservation purpose, sir.
preservation purpose, you have to just optimally maintain 10 ppm. That's all.
10 ppm is enough, sir.
Yes, but you
For
need to
more than
drain down your boiler completely. Huh? Wash your boiler completely after the shutdown.
then okay. Normally we are not doing. We are doing wet preservation. For that, we are Deha and cyclohexyl are adding, sir.
Can you not do this?
Okay, I will try, sir.
Just
Sodium
find it out.
sulfate.
I'll show you. I'll come back to that. Can you not do this? Empty boiler from high pressure. I can supply you the EPRI guideline for this.
Okay. Yeah, after emptying, we have to fill nitrogen, sir.
No, after emptying, you have to close all the valves properly.
So is it possible to drain entire water, sir, in the boiler?
There
I
are
don't
few.
think so.
There
Will
are
remain
few.
hot.
There are few non-drainable portions, especially in LP heater and HP heater. If you can isolate them, it can completely be dried. Only LP heaters and HP heaters are having some non-drainable portions. Otherwise, complete boiler is drainable, na? Right? Downcomers, your water walls, all these be drainable. है ना?
Yeah.
Your lines, even only the heaters which are coming in place, right?
Okay.
The LP heaters, HP heaters, and also reheaters. If you are having reheaters, normally your size of boilers may not be having reheaters, but if they will have those conditions. There you fill high pH water. Keep it like that.
Compared to this one, sodium sulfate is better, sir. We can go for sodium sulfate.
Yeah,
because how to ensure that whether it's drained or not.
We need to discuss little bit more on this together.
Yes, sir.
Okay.
Okay.
For that, you
Okay.
can note down my number
Okay.
798563
798563
5683.
5683. Okay, sir. Okay.
Okay. And if required, I
Okay.
can come down to Tadipatri to discuss
Okay,
with you.
please.
Okay.
Okay, sir, please.
Because
Okay.
it comes when I go to Kurnool. I'm already doing treatment in Kurnool, and I'm going to KPCL Bellary,
Okay.
JSW Bellary.
Yes.
I'm going
Yes,
to
sir.
Raichur Thermal KPCL. I'm a consultant for all of them, so I can easily come down for few hours with to
Please,
your plant and discuss. Tadipatri is
please, sir.
not far from Bangalore.
Hi, sir. Very near. 280. Yes, sir.
Yes, Anantapur, near Anantapur, na inside. You
Yes.
have to go right
Yes.
side inside. Yeah.
Yeah.
Okay. So now in the modern treatment systems, we need to maintain our system into this range. What you see, if you are below 105 kg per centimeter square boilers, okay, the pressure rating is below 105 kg per centimeter square, then you need to maintain your phosphate levels and your pH levels in this concentration. Phosphate up to 3.6 and pH up to 9.8. Okay, you will be happily surviving without any problem. Now this is for ASME guideline for low pressure boilers. Okay, low pressure from our Indian perspective. Otherwise, these are actually from the outer perspective. More than 10 kg per centimeter square is high pressure. So here the PSIs are mentioned, and here boiler feed water and boiler water are mentioned as per ASME. But I follow preferably EPRI. I'll go to EPRI. I'll show you. This is ABMA standard. Okay, American Boiler Manufacturer Association standard. Only for low and medium pressure boilers. These are the PSIs mentioned. These are the boiler water specification. And this is obsolete. Okay, IS standard 10496 was made in 1983 and never being revisited. Never was revisited by anybody. IS 10496. I don't know why they never gave enough consideration to the boiler feed water, but the boiler inspector will very well come and will check everything and will eat money. Okay, sorry to say very bluntly like this, but the truth is there. Okay, that IS specification should have been revisited, revalidated, and republished. As per our system, it is now obsolete. Okay, there are two kinds here. One is feed water at economizer inlet, and another is boiler water, condensate. All three were published, but never revisited. This is the EPRI guideline for less than 105 kg per centimeter square. Okay, where you will see that they have emphasized more on the cation conductivity everywhere. They have said that in the boiler water you need not check the specific conductivity or specific you may check, but it should always be higher than cation conductivity, right? And here in the DM water, it is said specific conductivity you check, but the cation conductivity should always be lower than specific conductivity. What I found in the other plants, one is in Orissa and another in Punjab, that their DM water specific conductivity was 0.08 in actual after calibration, 0.08, while the specific conductivity was 0.17. So that was clearly denoting that chlorides or sulfates were coming out. When we measured in ion chromatograph, we found chlorides. Okay. So these are the cases which I've seen in India, which I'm discussing with you. If you want to check this specific conductivity, 2.7 to 5.4 is the optimum. Phosphate is the most important thing here for your boilers. 0.2 ppm to 3.6 ppm, where the pressure of the boiler is less than 105. Other than that, they are telling silica should be maximum 850 ppb. Sodium should be maximum 2.3 ppm. Sulfate should be maximum 1.2 ppm in boiler. Otherwise, all the other places, it's lesser than or equal to 5. One most important thing which they have added after cation conductivity is ORP, oxidation reduction potential. This, if you are at AVTR or if you are using hydrazine in the system, you should be maintaining this ORP in the steam water cycle to get the magnetite layer intact. Okay, magnetite is Fe3O4 black colored layer. Minus 250 to minus 150 is the optimum range in the director outlet. In the economizer outlet, it should be minus 350 to minus 150. I will not read out everything. You will get these slides very soon from your HR, and you will be able to correlate everything. Now here ammonia from here ammonia is mentioned as somebody has opened his unmuted his mobile, I think. Here ammonia is mentioned as 0.2 to 0.5 is for mixed metallurgy. For all ferrous metallurgy, you can go to 1 ppm as well. After this, you'll see many reference slides for this, which you should maintain in your system or in a mobile to check. Okay. Now here the next one is above 105. The difference in below 105 and above 105 is here only in the boiler water, where you have phosphate 0.2 to 1.5. Earlier you were having 0.2 to 3.6. Okay, the chloride levels, the silica levels, it's 180 ppb only, above 105 kg. So there is a big difference between these two. Those boilers who are operating around 105 will be having some ambiguity in understanding. So let me help them if they have any problem in understanding. Now, SWAS instrumentation, it's quite important. It is like chemist working for you 24 into 7 into 365, giving you the right results if they are calibrated rightly. Normally, they do not go out of calibration very easily. You should have pH, conductivity, and conductivity, cation conductivity mounted there. Sodium also, if it is possible, mounted. Otherwise, you can check through ion selective electrodes also in the lab. Now there are earlier there were no ion selective electrodes for less than 20 ppb, but now they are available at even 2 ppb levels. Okay. SWAS instrumentations are important. SWAS instrumentation should be for director inlet, outlet, economizer inlet, mainstream, high pressure, heater drains as well. And this is your reference chart which you need to go through when you get these slides with you. Now, where is the superheated steam? Now, this dark points means core. You should always check this light circles or O are diagnostic. When something goes wrong, you need to check. 1, 2, and 3 are mentioned here. What are 1, 2, and 3? These are checking frequencies and whether this is required for PT. PT means phosphate treatment. OT means oxygenated treatment. AVTR is equal to what you are doing, hydrazine addition in addition to phosphate treatment. You're doing hydrazine addition. This is cycle chemistry monitoring system for different sample points. These are for makeup water, means your DM water. DM water should always have conductivity lesser than 0.1 microsiemens. It is clearly mentioned in EPRI guideline, and this picture has been taken from EPRI guideline and put over here, because I cannot supply EPRI guideline to you, because number one is they have a legal obligation that I cannot copy or reprint or give it to somebody else. Number one. Number two is I cannot, it is costing very high, 2.5 lakhs. So I cannot distribute it also like that. So specific connectivity, it is just I've taken a picture from there and mentioned here. Though my book is having abstracts from APRI guidelines, 70% of them inside, and that were taken after the permission of APRI people. This specific conductivity should be less than 0.1, sodium should be less than 2 ppb, silica should be less than 10 ppb. These are the latest guidelines available for DM water. Do we check all these things? The question is, if not, if the answer is no, then let us start doing it. If answer is yes, I congratulate you that you are doing a very good job. Now, mainstream reheat monitoring. This is the standards, reference slides. Now, symptoms indicating likelihood of scaling inside the boiler. What will happen when there is a scaling inside the boiler? What will happen? The first thing it should happen is the flue gas temperature will go higher. There will be an upward trend in the flue gas temperature over weeks or months. And if you do a visual inspection of the boiler tubes, when the unit is in shutdown for maintenance, scale removal can be achieved by mechanical means or acid cleaning. Mostly people go for acid cleaning. Normally they go for inhibited HCl plus 1% of ammonium bifluoride. In turbines, we see some deposits. These, the first left hand side top picture is typical of silica deposits. Okay, typical of silica deposits where it get deposited the edge of the blades. This is caused by morpholin, the CO2, and the formic acid and acetic acid, the morpholin and cyclohexamine. This one was caused by DEHA. By using DEHA, they have added more and more acetic acid that got carried over and that caused corrosion and deposition of iron on the turbine blades. So steam chemistry, it's, you need to control sodium, you need to control chloride, you need to control sulfates. These are very good things required. Sodium, you can use sodium analyzer either offline or online. Chlorides and sulfates can be indicated with cation conductivity. So if you maintain a cation conductivity, has been shown in these both the charts. Below 105 it is always less than 0.2, you see everywhere, and even above 105 also it is less than 0.2, except in the boiler, because boiler drum is going to get concentrated, right? So 15 is the limit above 105 and 32 is the limit below 105. So chloride and sulfates we can understand through just maintaining our cation conductivity properly. So these contaminants, if it goes along with the steam from the boiler, it can cause stress corrosion cracking or corrosion fatigue in the turbine blades. In the corrosion fatigue, it can assist the corrosion fatigue a little more because environment is one of the factor, because corrosion fatigue can anyway happen due to cyclic operation, maybe through several load fluctuations and load throw off and again load gaining. So that will always have corrosion fatigue, but presence of chloride sulfates will assist this corrosion fatigue to happen faster. Silica contamination means silica will deposit in the LP turbine blades, though it's not very harmful nowadays with our knowledge and conditions. We know the tighter guidelines right now. We know the DM water productions properly right now. We know the silica analyzer importance right now. But still, cracking a blade and having a deposition of blade are two different situations. Blades can be cleaned, the deposits can be cleaned, but once there is a corrosion or cracking of blade, it's a irreversible damage and takes a lot of time, energy, money, and efforts. So silica needs to be maintained below 10 ppb. Now regarding the cation conductivity, if cation conductivity is more than 2, I was talking about less than 0.2. Now here we are talking about 2. Okay. If cation conductivity is more than 2 for 5 minutes or more than 5 for 2 minutes, trip the unit. Trip the unit if pH drops below 7 in any of the circuit. Trip the unit if the sodium increases above 24 ppb in the mainstream. And follow the analyzer alarms. If you are having a SWAS, then SWAS analyzer should be equipped with alarms. Now here is a graph for you to see, boiler water silica versus pressure. You can always ask your operation to follow the pressure, increase the pressure according to the boiler water silica. If the boiler water silica is say 10 and you are having a pH of say 9 to pH 9, 7.8 or here somewhere, you cannot go beyond 1000 psi pressure. Okay, psi you can always convert into kg per centimeter square. Now about CPU, some plants are having condensate polishing units, and some plants specifically who are having air cooled condenser are also having condensate polishing units. Because there are a lot of chances that iron is getting picked up from the air cooled condenser and coming into the system. So CPU is normally, there are two kinds of CPU. One is with in situ uh, like MB, in situ regeneration. There you can regenerate, but that acts bad sometimes because either caustic or acid, if it is remaining in the resins, it goes into the steam water cycle. So the other one is, you have a uh, offline system where you take out the resin, you air hydropneumatically, you pump the resin into some other vessel, separate them, do the regeneration, mix them, rinse them fully, and then put it back into CPU system. But these are like resins only, same ion exchange resins, but having higher capacity as they should be operating at higher flow rate, can treat the water which is required, and they can withstand the higher temperature conditions. And about the treatment, there are three different treatments available. One is AVTR, which you are following. AVTR plus PT is what you are following, and which is okay all the way. And using of amines or carbohydrate are actually not good. And you should be maintaining an ORP, oxidation reduction potential, of minus 150 to minus 250. A ORP meter is very handy, comes around 5,000 rupees only. You can always purchase and use it. And there are so many companies being supplying this ORP meters. Oxidizing systems or treatment systems have now started coming up in India. Mostly, Adani's, Jindals, they are transforming, and they have started transforming. NTPC has transformed many and still transforming into AVTO, where they do not use a reducing agent and they maintain a positive range around 0 to plus 50. But this possibility can happen when you are having your DM water with 0.15 cation conductivity, number one. Number two, you are not sea phased cooling water system, you are having normal cooling water system, and if you are having a polishing unit, that will be an added advantage to go into AVTO, because any contamination can damage your pipelines to a higher extent. Then the third one, oxygenated treatment. The first oxygenated treatment in India was started way back in Naveli. Okay, Naveli, they had a uh, subcritical unit, but it was a drumless once through unit. So there they have started about 15-20 years back. They have, about 15 years back they started oxygenated treatment. We didn't had much idea about it. We came to know in 2011 that they are running like that, and that was a good thing. But in India, I was the first chemist to start oxygenated treatment in supercritical units, and it is still running successfully. Nothing is going wrong. In Adani, all the 6 supercritical units are running very well at Mundra. And then I ran in LPGCL. I straightly converted the system from commissioning itself to oxygenated treatment, the supercritical units, and they were running well till I was available in the plant. Because after me, all the good people have followed me back. So amines of lower volatility than ammonia exhibits excess thermal decomposition at elevated temperature. It increases acetates, formates, and carbon dioxide. The main alkalizing agent should remain ammonia. And here carbohydrazide is a derivative of hydrogen which releases carbon dioxide. So we must not use carbohydrazide. There we have to look into a little bit more whether it can work at a lower temperature also, at a ambient temperature also. Okay, we need to dig a little more. We can achieve lesser than zero point 0.2 or 0.15 microsiemens per centimeter square per centimeter in OT units very easily, and even I think we will be able to achieve it in your plants as well. However, this is not sufficient by itself. Major efforts should be applied to mitigate the generation and transport of corrosion products. So in AVTR, the iron in the economizer inlet should be less than 2 ppb if you are operating well. An unit operating with AVTO, it is around 1, and unit operating with OT in oxygen treatment, it is 0.5. So higher purity water where the degas cation conductivity is less than 0.2 and sodium is less than 2, not only critical to control the corrosion in the feed water, but also it's better. So it's almost 1742. We have not much of time left. We'll talk about PTZ zone. I've already told you PTZ. It is called phase transition zone, where you are operating more than the desired vacuum. If your designed vacuum is 0.91, and if you are exceeding 0.91, you are going to 0.92, 0.93, you are placing that phase transition zone from condenser into LP turbine itself. In condenser, the phase transition should happen. The steam must condense into water by releasing that latent heat of evaporation. But what you are doing at running at higher vacuum, you are forcing that phase transition to happen in the LP turbine itself. And when the phase transition zone happens in the LP turbine, the water droplets will have 200 times more concentration of the contaminants like chlorides, sulfates, or carbon dioxide, and that will damage the LP turbine. Now, temperature has effect. Here is the temperature, and here is the iron. You see this temperature range. It is that temperature range where your magnetite forms, but it can get dissolved. Okay, this also you must remember. All these are reference slides which you should go through at a particular time whenever you have some time in your hand. So all volatile treatment, what you are having, if you are having copper in the system, then you should establish an ORP of minus 150 to minus 350 depending on the metallurgy. The AVTR application target pH should be 9 to 9.3, as I've shown you in that table. Others are all your reference tables, reference slides, which will help you understand more. I cannot take more time than what is being allotted. Okay, this is where you have to be in the boiler, and I request you to be there. And these are some hideout things being mentioned. Phosphate hideout reaction happens in three types. One is maricite, another is SiHP, means sodium iron hydroxyphosphate, and third is precipitate sodium phosphate. Now, the phosphate hideout, all these three has different conditions, means different what do you call uh, in pH it will be different, in return the pH will be different. All these are mentioned in this chart. Here three, if you remember: maricite, SiHP, sodium hydrogen hydroxyphosphate, and third is precipitated sodium phosphate. This one is precipitated sodium phosphate. The difference in these three is mostly the pH. When the hideout happens in maricite, with maricite, the pH increases, and during the return the pH decreases. With sodium iron hydrogen hydroxyphosphate, you have with SiHP, you have in hideout pH reduces slightly. It was 9.2. It will reduce slightly. In return, the pH will increase. And if it is precipitated sodium phosphate, then pH will decrease drastically during hideout. So these are three different hideout mechanisms. Okay, and the return is again the increase of pH here. So these are typically three different hideout mechanisms, and phosphate hideout can happen from any of them: maricite formation, SiHP, or sodium phosphate precipitation. But maricite is the most common because we are keeping phosphates very, very higher than the limits. To control them, now EPRI had come with that phosphate limits of this. Lesser than 105 kg, phosphate limit is 0.2 to 3.6, and higher than 105, phosphate limit is 0.2 to 1.5. This has controlled all the three phosphate hideout mechanisms properly. When the phosphate hideout happens, please do not add more phosphate into the system in any case, because phosphate hideout happens because of the thickness of your magnetite layer. If you reduce the thickness of your magnetite layer, definitely you will be able to achieve the desired results. When it is uncontrollable, the phosphate hideout, please go for a boiler acid cleaning. Right? So here is another
So can you
chart.
wrap up in 10-15 minutes, sir?
Yeah? Pardon?
Can you wrap up in 10-15 minutes?
I know that you are having lesser time, and that is why I am just trying to wrap it up.
Okay, fine.
Right? So mechanical carryover is one which you should know. See, all these are reference slides now for you. Okay, there are many reference slides which you should go through and inform me. There are two slides importantly which I must mention you, that if your water is free of CO2, then even 0.5 0.5 ppm of ammonia will let you take 10.2 pH. Okay, if you are having carbon dioxide free water. But if you are having carbon dioxide in the water, then these are the scenarios where it will happen. Even 2 ppm of ammonia may not be able to take you to a higher pH levels. Okay, it will come to 8.6 only. So that is the case. Even if I want to take it to 10 with say, if it is I'm having 0% 0 ppm ammonia, I want to take it to 10, pH of 9.8, above 9.8. 9.8 can be achieved by 4.2, 4.3 ppm itself. But if it is having CO2 at say 4 ppm level, then I may not be able to achieve even pH of 9.6 properly, even after adding 8 ppm of ammonia. So you need to install caustic breathers to your DM storage tanks and caustic breathers and condensate storage tanks. These are the action levels, and here I finish. So I would like to request you some questions if you have, and you can, otherwise you can post all the questions to your HR and let HR talk to me, and let us discuss with you about the this what you call use of DEHA. Okay, the person from Tadipatri. Sir, may I know your name? Who was
Sir, Umesh.
Umesh?
Umesh Babu.
Umesh Babu. So, Mr.
Yes, sir.
Umesh, we'll have a discussion. Sometimes you have my number now, so we'll have a
Yeah.
discussion on it. Okay.
Okay.
How to better use them. Okay. Because sodium sulfide was proposed by one of the Englishmen earlier to me, but I still have not adhered to it because I never wanted to go with sulfate ions in the system. Okay.
Yeah. Yes, sir.
Right. So let us discuss it over.
My intention is that one,
Hmm.
we are using hydrogen at ordinary temperature, it won't affect. So what is
Yes.
the next step for that one?
Yes.
So just now
Actually,
you
what
just
what we are doing.
that will increase the conductivity and everything this one. So just what I wanted to do, sir, just I want to preserving purpose that I am going to sulfate. Sodium sulfate I want to use.
I'll tell you what we are doing actually now. Nowadays, what we are doing, I must tell you that nowadays we are using pegging steam or an auxiliary boiler to heat up the DM water which we are filling up in the boiler, so that all the oxygen is released from the deaerator. Okay, and then
Okay.
we are filling it with hydrazine and ammonia, so that hydrazine whatever is over there, and when we have pressurized the system to 3 kg, we keep it pressurized so that nothing bad happens to our system later on. This is our intention, and this is what we are doing. Okay, even in supercritical boilers also, we are following the same. We are using either pegging stream from another boiler, and even in Bellary also we are doing the same. Okay, we are using pegging stream from another boiler to heat up the DM water which we are adding through deaerator in the boiler. Okay, so that there is no dissolved oxygen remaining into the water. No dissolved oxygen is there into the DM water which we are adding, and after that we add hydrazine and ammonia and keep it pressurized. We try to have all the valves properly closed. Now we are going for this what you call nitrogen filling in the systems. Okay, but yes, we can always discuss about this, right? What you are saying, we can always discuss. So this is my details. You can note down. You all can note down if you want. You can connect me directly or through your HR so that I can assist you in the future. I am a chemical supplier as well. I do supply to Dalmia Cements and Orient Cement. Okay, but my consultancy goes free of cost to them. My training goes free of cost to them wherever I am supplying chemicals.
Okay, sir.
Anything I can help you all with now? Any other
Sir,
question from any other? Yeah.
sir, one more case, sir. So
Yeah.
what I have observed, so our boilers, our capacity is 25 megawatt. If it is 25 megawatt, all values are maintaining well. So I am going to maintain at 1 to 2 ppm. That will remain like that only. Suppose if there is any load throw off to 10 megawatt or 15 megawatt, that phosphate level will increase to 4 ppm.
Okay.
This is phosphate hideout, isn't it, sir? Even
Yes.
though I am maintaining very low values, that
Yes,
phosphate levels are getting high.
it is phosphate hideout, but do not add more phosphate into it. This is phosphate
No,
hideout.
no, no, that's why we are maintaining less phosphate, sir. Instead of 3.6 ppm, we are maintaining only 1 to 2 ppm.
Fantastic. Very good. Another thing you should start doing is maintain a little bit lesser hydrogen concentration.
Hydrogen, sir?
Yeah,
Uh-huh.
because hydrogen thickens that magnetite layer. So
Okay.
maintain a little lesser. You may be maintaining 0.02 ppb in the boiler.
Yes, sir. 0.02 to 0.05.
So reduce it to 0.01.
Okay. Okay.
Okay, but ultimately, if your boiler is old, we have to go for acid cleaning.
Okay, sir.
Okay.
Okay, sir. Okay. Okay.
Okay. So, Umesh ji, I'll request you to send your number and other things.
Sir, one more thing, sir. Sorry for the interruption. One more thing, sir. So most of our boilers are this one ACC based, air cooled condenser.
I know.
So deliberately we are maintaining high pH.
Yes,
Just
you
because
have to. You have to.
Just because that is having a corrosion prone area, that one.
Yes,
ACC is
yes, yes.
how to preserve this ACC, sir, during idle condition?
Sir, seriously telling you, there is no answer. Seriously telling you, because ACC is not very common to me, because I have always worked in very high pressure boilers and always worked with, say, started my career with the PowerGen UK and was in Tata Power, Adani Power, the bigger
Yeah.
plants, the GE Power America, all that.
Under what about connection?
But air cooled condenser, I have seen some, and those are very much corrosion prone because of the CO2 which is coming in. Now, if you want to preserve it, you don't have a place where gas cannot escape. You cannot pressurize the system with any gas.
Yes. No, we can't. Yes, sir.
Yes, we cannot actually. So, frankly telling you, what other peoples are doing, also the condensate system preservation is only through ammonia, nothing else.
Sir, if it is ammonia, sir, the dissociation is very fast.
Yes.
So that will not work out in ACC. If it is ACC, we have to go for cyclohexylamine. Then only it will work out. It is slowly that will dissociate, that will maintain the pH in ACC level also.
No, that is what you are thinking. But cyclohexylamine has given bad results in many of the ACCs in India.
Isn't it, sir?
Yeah. So.
Some consultants, particularly, they have recommended
just a moment. Just a moment.
You have to use cyclohexylamine in ACC. Right?
Yeah.
So in always, I have seen, sir, so many papers. I have seen ammonia is strictly prohibited, but you are recommending only ammonia.
No, actually, EPRA is also recommending ammonia. It's not me only. Okay. EPRA guidelines, ASME, they are all recommending ammonia. There is no cyclohexamine recommended by any standard company. I am following international guidelines. I am following what even the 270 megawatt Jordan has put a 270 megawatt unit. 217/2 with ACCs. Okay, they are also following EPRA guidelines. Even Chinese are also following EPRA guidelines, though it is America versus Chinese. So all of them, they say ammonia only. Ammonia is having dissociation constant in effective in the boiler. Okay, where the water is boiling. Here it is condensing. Okay, so to preserve the boiler and preserve the condenser is two different things, Umesh ji. Okay, these are two different things. Cyclohexylamine, you find in the Google, just Google it, degradation product of cyclohexylamine. You just Google it. You will find many bad things about cyclohexylamine, while you will not find any bad thing about ammonia. Though the dissociation constant is less, this 10:1, but it is when it is condensing, water will condense first, and then ammonia will condense, right? But ultimately, it will condense, na. It will not be in a different phase. Ultimately, it will condense. The only thing is the early condensation will not happen with ammonia, right? Cyclohexylamine, you see the partition coefficient. Morpholin in this case will work better than cyclohexylamine and ammonia because its partition coefficient is only 1 to 1.4, right? So morpholin will settle down faster with the water. But if the water is having carbon dioxide, then carbon dioxide is the first thing which will condense earlier than water itself.
Yes, sir, correct.
Okay, so we have to take care of carbon dioxide in any case in the system. Through any means, we have to take care of the carbon dioxide in the system. So the first thing is, let us control the carbon dioxide and let us check. Let us check the ORP of the system. Let us go to reducing environments and check, right? And then let us check what is happening with early condensation and late condensation, right? Rather than moving away from the normal chemistry which worldwide the best organizations are using, people like Ion Exchange, they have come and they said that let us put spargers inside your ACC and let us spray ammonia. Like in ESPs, they spray in ammonia. They said that let us spray ammonia. We said it will not work. Okay, because it will ultimately go to a condensate storage tank and will escape. Let us find out some other way. The best way is to block all the places from where air can come inside or air can get ingressed. All right.
Okay, sir. Okay, nice. Thank you.
Anything else? You can just connect me on WhatsApp. The same number is WhatsApp. Okay.
Yes, sir. Definitely.
Both the numbers are having WhatsApp, which are in front of you. Now
Yes,
it is already 6 p.m. and Madam Shushma ma'am has given me time till 6 p.m. Ma'am, anything else I can do? Please let me know. And otherwise, we'll share the PPT. Now, I have shared it to Mr. Sunil Shah already, and I'll share this PPT to Shushma Madam also today. So they will share the PPT to you because I am not having your email IDs. Okay.
So that's thank you, Sumitra ji. I would request participants to come forward for any questions related to today's subject.
Yes, madam. Okay, madam. Okay.
Now, Mr. Umesh Babu has participated very well. Any other people having any question? Mr. Umesh Babu, please share your number with me so that I can connect with you.
Yes, sir. Okay, sir. Definitely.
Acha, Sunil Shah sir, Sunil Shah ji has also
participants, I am giving you 3 to 4 minutes of time to just think about some query related to, if you have some cases related to this one at your plant unit, please put either you unmute yourself or you can put the query in your chat box. By 6, 7, or 8 minutes, I will be sharing the posters and the feedback for today's session.
Okay.
Sir, one problem is this, sir. Fire side chemical problem, sir. So at present we are using American coal, Russian coal, and this one, sir, alternate fields.
Just a moment.
So what we have observed some scaling on boiler side, sir, fire side.
Okay, fire side you are talking about, right?
Yes, sir. Yes, sir.
Fire side you are using different composition of coal.
Yes,
just hold on for a while. Huh? Suncho, hello. So fire side you are using different coal, and that is what I have seen in Chittapur also. You know, the cement plants in Chittapur, they were using coal and plus some plastic materials which are needs to be burned and all those things, and they were having some depositions in the fire side. Now the coal composition needs to be checked for slagging and fouling index. Okay, coal ash analysis. If you can share me the ash analysis, ash elemental analysis, and ash fusion temperatures. Okay, if you can send me these two, I will help you out with its slagging propensity and what needs to be blended with it, because only coal blending is the answer for this particular problem. This particular problem can be solved by coal blending.
The problem is different, sir. If you are using only coal, that's okay. We are using lot of alternate fuels, agro waste, and this holders, turmeric waste. So many, 8 to 10 types of fuel we are using.
Then you are facing a complex situation, right?
Yes, sir.
You are facing a complex situation. I can try out one solution for you, that if possible, please try and use 100 to 200 ppm of magnesium oxide powder, green color magnesium oxide powder, with your fuel.
How it works, sir?
It will not let the slag happen. Okay, it will remove the shoots, black color shoots, and it will not let the slag happen inside the system.
So can you go for dolomite, sir?
Mm-hmm.
Dolomite.
No.
It's having 30%.
No. That
Purely MG.
That can help, but this thing will increase. The percentage requirement will increase. That can help because the dolomite will also take care of the sulfur inside. But sulfur may not be the real problem now for you. So that is why I was talking about MgO green powder. If you want to use dolomite, you can use, but the concentration required would be more than 1000 ppm then. Have you understood, Umesh?
Yes, sir. Some more clarification is required, sir, because we are facing problem. So we have
Umesh, I would request you to please connect with Soumitra individually and get your problem resolved. Is that okay, Soumitra ji?
Yes, definitely. And his plant is quite near to me. You know, I can travel to that place as well. No issues.
Okay. Great. So Umesh Babu, you may please connect with him directly and have your query resolved, na?
Okay, madam.
Okay. So apart from Umesh, does any other participants have any query? Yeah, please go ahead. Ravi.
Yes,
Ravi, you may please unmute yourself. Yes. Go ahead. Go ahead. Ask your query. We are not able to hear you.
শুনছো কবে থেকে ডাকছি আমি ওই লেটটা জেলে এই লেটটা অফ করো না আমাকে
Yeah, apart from Ravi, anyone has query?
Ravi, we are not able to
You are
hear
on
you.
mute. Sumitra ji, you are on mute.
Ravi, we are not able to hear you. Can you please tell me?
Or you may put your query in the chat box.
Yeah, that's also. Ravi, anything you want to tell? Okay, so internally the
Sir, I will say on behalf of Ravi sir. I think he might have discussed with this one. So they have opened boilers recently. Now we are using single compound, that's low pressure boiler, WHRS. So what they have observed, sir, we have observed instead of black color, we have observed some slightly reddish color we have observed in the boiler. So that is very nicely coated. No pitting action has taken place. Only very nice. So our treatment is correct or not? He wanted to ask.
What is the location?
Tadpatri, sir. Tadpatri.
Okay. See, as I told you, that below 200 ppb of dissolved oxygen during normal operation, pitting will never take place. Okay, I told you during the training also. And the second thing is that this red color is indicating presence of hematite instead of magnetite. Now, if you are checking iron in the boiler or in the steam and finding it higher, check total iron. Okay, if you're checking total iron and finding it higher in the boiler and the steam, then probably I can help you. Okay, otherwise it is okay to have red color instead. So phosphate iodide EPT best or not? Yes, EPT not. It is EPT is the older guideline. Now it is PT, phosphate treatment. Okay.
Sir,
now it is phosphate
in waste
treatment.
boiler, in wastewater boiler, we are not dosing any phosphate and all these things, sir. Only single compound is there. That is they have based.
No, actually, Mr. Ramakrishna has asked, so I'm replying him.
Okay, sir.
Okay. For for HRSG, for heat recovery boilers, if you are getting red color, actually it is bad. If you check the oxide layer thickness, DWD is one of the measurement system where you take out the pipeline of 6-inch or 12-inch length from high heat flux zone and then clean it from clean it externally. From the external surface you clean it, measure the inside surface area and measure the weight of that pipe and then put it into inhibited HCl, 5% HCl for probably 4 hours and then take it out, clean, dry it out and again measure the weight. You will get a DWD or deposit density index we also call, about ranging from 25 to 200 milligram per centimeter square. So that will determine whether that is good or not. But the most important indication what we need is the HRSG stream having iron? Is the iron getting carried over from the HRSG stream? Is the HRSG pushing any turbine? Is the HRSG what you are talking about is pushing any turbine? Umesh? Hello, Umesh?
Yes, sir. Sir, that I am not sure about that one. I have to encourage this.
So please, I've shown you the slide where my numbers and everything was there, and you can take my number, etc. from HR also. If you all want, I can again show you my slide. where my numbers are written. Okay, you may take a screenshot if you want, or a picture if you want.
So Sumitra ji, I would just request you to type your number in the chat box. People will have the permanent, that number will be permanent on the MST meeting.
Fantastic idea. Fantastic idea. I'll do that. Ravi Kumar said
So
actually.
yeah. So participants, I have shared the post test and I'm sharing the feedback for today's session. You may please go ahead and complete it. In the meanwhile, I would request a few of the participants to unmute yourself and speak about today's session. So link has been shared and this barcode is there for your posters. In case you are attending this session through your mobile, please attempt the posters through your mobile by scanning this barcode. Posters.
Yeah, Sushma ma'am.
Yeah.
Yeah, before
Yes,
actually I want to just leave. Before that, I just want to have thank Sumitra ji. Just for the
yeah, that's correct. So I thought ki have a verbal feedback from few participants on today's session and about the trainers. So I was just waiting from the participants. Then I would have hand over to you to have your comment on today's session. So let's hear one or two participants.
Okay.
But it's a tough one. So I would request Umesh, who have been very much engaged in the sessions, to have a feedback for today's session. Yes, I'm able to see a few of the participants has commented about today's session in the chat box. Umesh, may I request you to please unmute?
Yes, madam.
Yeah.
So, Mesh Babu, you want to say something more?
Sir, I will tag personally, sir.
Yeah. Sumitra ji, I would just request you to unshare your screen.
I'll do that.
Sir, the only thing is, sir, in WHRS we are using Indian 5203, that is single compound, sir. That will take care of everything what they are given. That is, they have based chemical. So since from 2-3 years we are using the same chemical. After opening the boiler, we have observed that boiler internals.
So you understand now, na? You understand now, na? Deha causes acetic acid and does not take care of oxygen completely. Now you understand?
Yeah, yes.
After seeing
But
it red.
They didn't told anything about them because that is trade secret. They don't tell. But after requesting, they have disclosed that one. This is they have based chemical.
Now, the same thing has happened in Vijayanagaram, SMAL, Shraddha Metal and Alloys. Same thing has happened. Okay, they have destroyed the boiler using that chemical.
So, Sumitra ji, we are able to see good comments for this session, and I am pretty assured that people will not unmute themselves and speak. So this is a demerits of the online sessions. I would request the coordinator and the organizer and the Sunil Shah from TPMC to comment on today's session. Sunil, over to you.
Yes, madam. So first of all, thank you, Sumitra sir, for, I think I was not able to join on the time because I was traveling. I reached at the time when the training started. But initially, when I discussed with Sumitra ji, I think he immediately told, yes, I will able to give this session. So I think that was very prompt yes response from him to deliver this session. He told that this is basically a vast topic. It is not to be delivered in 3 to 4 hours. It is a 2-day session. So I think for that, he told that we would like to have this 2-day session. We would definitely, I think next year we would like to have this at Aditya UTTC, where all our participants from the units will come and have this session. But to crisp and what we call is make it in a package form in 3 hours, it's very commendable. I able to learn quite a few things. I still want to learn on this session, but I think for the benefit of participants and our units, I think this was a very enlightening session. I think this type of session we are doing for the first time for the boiler water chemistry in our UTCL. So many thanks for to you, sir, and we will continue. Hope we will continue this journey onwards.
Right, Sunilji. Thank you so much.
Sorry. So thank you, Sumitra ji. The way you are taking the session so coolly, so patiently, मतलब आपको देख के लग रहा था, yes, you are going to take 2-day session.
Yeah, I can.
But somewhere
I can speak
I
for
know, I
7
know.
days on any of the things
I
on
know.
in water.
Yeah, I know, because the way you have taken and very coolly and I really appreciate what Sunil has said. Ki you have converted whatever the topic coverage in a 3 hours. So that's a commendable. Yes, of course, we are expecting such type of session in the future, and we will let you know when to have that. So thanks a lot. Good feedback, good comment from the participants also. So thank you from the behalf of Ultratech to you.
Welcome, ma'am, and thank you for the opportunity given to me to showcase my ability as a consultant. But my chemicals, as I told you, will come with free of cost consultancy. So people can believe me. The boiler water, I cannot supply any chemical because I do not recommend any chemical apart from ammonia, hydrogen, and TSP. But cooling water, I can help a lot, all of the people. All right.
Okay.
Yeah. Next session, you can plan on cooling water treatment for 4 hours, FOC. Okay. In the month of November, towards the end, if you want to. That will be FOC again. Sunil ji.
Okay. So basis on my Sunil's
Yes, sir.
recommendation, we will go ahead.
Yeah. Sunil ji, you can have another 4 hours session in the end of November on FOC basis.
Okay. And yeah, Miss, I think that point I also forgot to mention. This session was conducted slowly on the free of cost basis by Sumitra sir, in spite of having many engagements. So we tried to change the dates, but since he told that okay, he's traveling and will be available today and tomorrow. So again, for that, thanks for sparing this wonderful time and giving us the opportunity to leverage knowledge from you.
Thank you so much. And you all are always welcome. Whenever you all people are having some problem, please connect me back. I've shared my numbers. You can WhatsApp me. I may not be available on phone on all the times.
Yeah. So thank you once again, Sumitra ji. If you want to drop out from this session, you may please go ahead. Yeah.
I'll do that, ma'am. Thank you so much. Yeah.
Thank you.